Good morning, ma'am.
Good morning.
Yes, ma'am. Good morning. We are going to start by 5 minutes.
Okay, fine.
A very warm good morning to today's resource person, Dr. Nirmala Devi Madam, and dear participants. Today we have with us Dr. Nirmala Devi, Principal, Dona International Institute of Assam, India. Prior to associated with Dona International Institute of Assam, ma'am had held previous position as Assistant Professor Senior in Chemistry, Central Institute of Petrochemicals Engineering and Technology, CIPET, Jaipur, Rajasthan. She was associated with National Institute of Technology, Nagaland as an assistant professor. She was an adjunct instructor of chemistry in Huston-Tillotson University, Austin, USA for a short period. She is a recipient of very prestigious Senior Research Associate, Full Scientist, CSIR, and worked in Indian Institute of Technology, Guwahati, Assam. She was a recipient of UGC Dr. D.S. Kothari Postdoctoral Fellow and associated with Guwahati University, Assam. She had many professional recognitions and received many awards. Few of them are National Award for Technology Innovation by the Ministry of Chemicals and Fertilizers, Government of India, in the year 2011-12. She was a recipient of Young Scientist Award by the International Academy of Physical Sciences in 2011. She was a recipient of very prestigious Women Scientist Award in 2016 by Department of Science and Technology, Government of India. She had more than 25 numbers of publications in national and international journals. She had presented many invited talks in different conferences, workshops, and the faculty development program. She was associated with different professional bodies. Few of them are member of American Chemical Society, life member of Asian Polymer Association, life member of Indian Science Congress Association. She was associated with Assam Science Society as a life member. She is associated with Electron Microscope Society of India as life member. We are very happy that ma'am is with us. Thank you, ma'am, and over to you, ma'am.
Thank you, Dr. Jyotika, for your nice introduction. Thank you, Director CIPET Guwahati, Dr. Hare Krishna Deka, and all the organizers of the organizing committee of this STTP. And today, let me start the topic. I think most of the participants are from different colleges and institutions in India, faculty or student. May I know their faculties?
Research scholars are also there, postgraduate students and graduate level, few students are also there.
Okay. Thank you, Dr. Jyotika. Let me share the slide. So I will go through accordingly. Sometimes I may go for a little bit of in the research level, and sometimes for basic for targeting the students of college and research scholars. So I will try to cover most of the topics, revisiting the plastic materials with an overview of utilization of plastic waste and its technologies. So am I audible, and is the slide is visible?
Yes, sir.
Yes, ma'am.
Thank you. So I'm directly going to the topic. So the topic of our today's presentation is revisiting the evolution of plastic materials with an overview of utilization of plastic wastes and its technologies. So let me share this first slide just to warm up. Can you see something here in this slide? What is this? Is there any guess?
Footprints.
Ma'am, footprint.
Footprint. Okay, so these are footprints. So these are not as usual footprints that we say, but they are something different. Can you see the grasslands and what are there? So they are called ecological footprints. They are called what? They are called ecological footprints. So why I am telling about this ecological footprints in the first slide? The thing is that this earth has a limited amount of resource, a fixed amount of resource. that is productive land and water that we can utilize. So what is an ecological footprint? A ecological footprint is that footprint that amount that a person needs to sustain his life on this earth. So that amount of resource means in this resource, it is included productive land and water. So it should be productive land and water. That means omitting ice caps and deserts, which are mostly unproductive. So the amount of productive land and water we need to sustain our life on this planet is called ecological footprint. Am I right? So here, these are your ecological footprint. I think you have already idea about what's ecological footprint. Everyone on this earth, when we live around maybe for 80 years or 90 years, we leave some of our footprints on this earth. Sometimes it is smaller, sometimes it's bigger footprint. But we all leave our footprints on this earth by consumption of its resources. So if we compare the ecological footprint, so how big is my ecological footprint? How, as a citizen of a country, how big is my ecological footprint, or my countries, or my citizens, or my countrymen's ecological footprint? So we are comparing here to get an idea that how much resource we are consuming every day and what we need to do for a future, or for a good future, to to make a sustainable living. So this ecological footprint, if you compare, you can see here USA has, what is the ecological footprint? 8. It is given in hectares. So 8 hectares. So China has 2.2. Mexico, here you can see Mexico 3.0. Just for comparison only, I have given some of the countries. France has 5. And what is the global average? Global average is 2.7. I think now we have one concern about what is about India. What's ours? Ours is 1.2 till today, but it's increasing. Around 6 years back when I saw, ours was 0.9. And now after like around 6 or 7 years, it's increasing, it's becoming 1.2. So if we go for the biological productive land and water, or there's another term in biology that is biocapacity. So biocapacity is 0.45 only. So capacity of this land, biocapacity. So we are exceeding, the nature has what amount of nature can give us, we are exceeding that limit. Our is 1.12. That means though we are very less compared to USA, it's only around 1/8, or China or Mexico or France or global average, yet we are exceeding the biocapacity. 1.12 is also higher. We need to maintain 1 or below 1. There is the stable one. In that way only we can sustain as a humankind. So how we can shrink? The question is how we can shrink our ecological footprint. That is the thing. And for that, we as a polymer chemist, or we as a chemist, we go for green chemistry or sustainability. One is green chemistry. The way it is not an environmental chemistry. First thing is that we should not confuse about environmental chemistry. That is different. Green chemistry is totally different. Environmental chemistry covers all about your earth, air, water, everything. But for a green chemistry, it goes to from laboratory scale. How a product is designed, it goes only up to that. So how can you shrink our footprint? We as a chemist or as a polymer scientist, we can reduce our footprint by utilization of green chemistry. Number one, the concept of sustainability. Sustainability, we all know about the sustainability. That is your utilizing the resources without compromising the need of the future generations. So utilizing the resources in a sustainable way, so that without compromising the need of the future generations, that is your sustainability. And the third one is the design for waste to wealth. That is the main topic, or the overall topic of this course. That is design for waste to wealth. That can also reduce predominantly this ecological footprint. That is the main idea of why we design for waste to wealth. So coming to the next slide, we see here that USA has 8.0, 8 highest ecological footprint. So everyone likes to live or wishes to live like a life once, like a life in USA or like there. So, but see, as per ecological footprint, they are using 8. Their ecological footprint is 8 hectares. That means if every citizen on this earth lives like a person in US or a person as a US citizen, then how much resource we are using? Just do the simple math. You will see that how many earths we will be using. If everyone on this planet live like the average citizen, it's just average citizen of US, then do the simple maths based on the world population of 2012 only. Now it's increasing. The 7 billion is now it is 7.61 billion. But for simplicity, I have given only 7 billion people. So if every citizen on this earth lives like a people or a US citizen, then we can do this maths. How much land or water, how much earth we are needing? 7 billion people. Am I right? This is world population. 8 hectares per person. This is ecological footprint of USA. 8 hectares per person. Ecological footprint. This data is coming from that. And we have one planet. So what is the, if we estimate the overall like total biologically productive resource or land and water on this earth, omitting the ice caps. Remember that we are omitting the ice caps and deserts. Then the available this productive land and water is 12 billion hectares. What is that? There is 12 billion hectares of land. That means if we divide the 7 billion people on this earth, everyone is using 8 hectares per person. That means one person is using 8 hectares. 7 billion will be using how much? 7, 8, 56. Then you divide by 12. Divide by 12, you will be getting 4.7. That means we will be needing 4.7 planets at this moment. We will be needing 4.7 planets, 4.7 Earths. That means around 5 Earths at this moment, more than 4 Earths. Is it possible? We have only one Earth. We have only one Earth. So what is the solution? The solution that humanity demands more than the nature can generate. Nature has some regenerating capacity. It can generate, it can renew, or it can regenerate every time. But the thing is that we are exceeding the limit. We are exceeding the limit that nature can regenerate. So if we go in this way, then at this moment, we will be needing 4 more Earths. So this rate of consumption cannot be sustained. This is not a sustainable way of living. So what is the solution for our, as a chemist? Moving to the next slide. Sorry, the slide is not moving. So maybe it is frozen. So it will come. Okay, fine. So if you go for the next slide, then we'll get that we have only one Earth. So by 2010, humanity has already used 1.25 Earths. If we compare in the next slide, then can you see my slide?
Third scroll is coming. It is not changing.
Let me stop it and start it again, I think.
Ma'am, you can click there and you can check whether it will move or not.
Yes, yes. I will join it again, then I think it's not. Is it coming now?
Yes, ma'am.
Yes. So estimated global ecological footprint. So you see, in 2003, humanity have used the equivalent of 1.25 Earths. By 2030, we will be using 2 Earths. If we compare the overall, now the overall, what is that? 2.7. The ecological footprint of average human, like world average is 2.7. Now 2003, it is equivalent of 1.25. We've already used. If we see that from 1916 to 2008 ecological footprint, here you can see that by 2010 we'll be using like 2010 already 1.5 earth humanity has used. Now by 2050, you can see here by 2050, if this goes in this way, then global average is also high. No? So we will be using by 2030, we will be using 2 earths. And by 2050, we will be using 3 earths. This is the global scenario. It's increasing every day. So we need a sustainable living. That is the thing. We need a sustainable living, reduce the consumption, enhance the productivity, and a lot of things we will going to discuss here. So in 2015, there was a book that is your Sixth Extinction and Unnatural History. That book owned the your Elizabeth Colbert, owned series science writer, and works in New York Times. She owned the Pulitzer Prize for the book The Sixth Extinction. So predicts there is 6th extinction is coming, and it was your published on your Science Advances. So you can, if you are interested, you can go through the book, one of the good book. So our responsibility. So what is our responsibility? Our responsibility is as citizen or polymer chemist, one single goal, and that is the sustainability. The meeting the what is sustainability that I have already said, meeting the needs of the present without compromising the ability of future generations to meet their own needs. Meeting the needs of the present without compromising the ability of future generations to meet their own needs. So the one other word is coming, that is our common future. As a humanity, we all have a common future. There are 2 terms, tragedy of the commons, and other is the our common future. That was explained in Brundtland report. So in the Brundtland report, what is explained? One, there are 2 new terms are there. One is tragedy of the commons. This is environmental pollution, climate change, which are like resources are common, but no one takes the responsibility for the climate change. Who will take the responsibility? Which country, which citizen, who will take the responsibility? But everyone are using air, water, everything we are using. But who will take the responsibility of changing the climate change or changing the environment or deteriorating the environment pollution or the environment pollution, whatever you can say? Who will take the responsibility for that? But there is no barrier. There is no barrier in as a climate or as an environment or as a earth. There's no barrier between the countries, because you see, US, we have seen that US has 8 ecological footprint. Even we have 1.2 ecological footprint. We are polluting the environment. But in Antarctica, you will see the ozone hole. Is there any people there who are creating pollution in Antarctica? I think no. But ozone hole is there. So have you ever questioned yourself why the ozone hole is there? We are creating the pollution. So there is no barrier. The nature has not created any your boundaries. Political boundaries are created by us, by humankind only. Nature has not created any political boundaries. Technology, but the technology does not have any political boundary. Technology can go beyond the boundaries. So these are called the tragedy of the commons, climate change and all that tragedy. That we are using the common resource, but no one is taking the responsibility of deteriorating or the consuming the resource. No country will take the responsibility. No citizen will take the responsibility, but all are using that air, water, whatever that we can say, petrol, diesel, or whatever we can say, or the polymer or plastic, the last one, like the youngest member of the family. Now, so as a citizen, we have a common future. So chemistry for a sustainable common future. So what we do, we go for green chemistry. So in the green chemistry, in the last time, in the last lecture, one STTP I said about green chemistry, and there was a questions letter where people wanted to know about green chemistry. So I have inserted this time the slides of what is the green chemistry. There are key ideas of green chemistry. So there are 6 ideas I have given, but there are 12 principles in green chemistry. The key ideas are in simple. For as a lemon, there are 6 key ideas. That is, it is better to prevent waste than to treat or clean up waste after it is formed. Number 1. Number two, it is better to minimize the amount of materials used in the production of a product. Number three, use and generate substances that are non-toxic. Number four, it is better to use less energy. Always. It is better to use renewable materials when it makes technical and economic sense. Number six, it is better to design materials that degrade at the end of their useful life. So these are the 6 key ideas. Based on the 6 key ideas, 12 principles are forwarded that were given by Warner and Paul T. Anastas. So first formulated by them. So presidential green chemistry, on the basis of them, every year one award is given, that is a Presidential Green Chemistry Challenge Award. And you will be happy to know that most of the Presidential Green Chemistry Challenge Awards are given to polymer chemists. In the 2005, I've given only one example. You can go through sometimes the water, which people are getting the, or which companies are getting the Presidential Green Chemistry Challenge Award. In 2005, BASF Corporation, you know about BASF, I think. BASF Corporation won the Presidential Green Chemistry Challenge Award. Also, another was another company, also Midland Company. Midland Company also won in the same year the Presidential Green Chemistry Challenge Award. This BASF Corporation, they developed one primer that, you know, a coating. A primer is your inner coat of a paint. So developed a primer which reduces the VOC by, VOC means volatile organic compounds, which reduce, because normally a paint or a primer have lots of, more than 70% of the solvents or VOC, volatile organic compounds, which after drying or the curing of the paint goes to the environment. That is the main concern of the paints about the environmental pollution. But this primer that developed in 2005 reduces VOC by 50%. So rapidly cured by sunlight. Number one is reduces VOC by 50%. That means less solvent, or either they've used some benign solvent. Second one, rapidly cured by sunlight. That can be rapidly cured by sunlight, because most of the time all the paints are not cured by sunlight. Because for industrial paint and some other paints that are used in marine, or this type of paints are not always cured by sunlight, but this was rapidly cured by sunlight. So it has given 3 advantages. One, less waste, that means low VOC, less waste. Reduced energy, that means reduce the drying energy. Third one, greater throughput. It was throughput was very high, very good. And it served the, or it was along with a line of triple bottom line. There's another term that's called triple bottom line. So what is triple bottom line? Every technology or every design if we make, then what is that? There are 3 things. Though we always support the green chemistry ideas, but most of the time it does not work, or it does not giving the, it is not giving the better product. Then what do you think? Because it is not going to the market. The work you are doing may be the best work, but it was not going to the market due to the cost reasons or due to the business purpose. So thing is that there is always a relation between business, profit, and planet. That means there are 3 things: people, profit, planet. People, sustainability living, or the people's advantage. The people, number one, always have to see about the advantage or what is the need of the people. As in people, profit. What is the profit? Business. From the point of business view or from the profit view, how much profit is it giving compared to the existing product? Third one is the planet, about the sustainability of this earth. So these 3 things are interrelated, they are correlated. If we draw a Venn diagram of these 3 round Venn, if we circle, if you draw, then the middle portion will be the triple bottom line. The intersection of the Venn diagram will be the triple bottom line. That is the bottom line of people, profit, planet. Both of the 3, it will do. So the next slide, again, it's going to freeze. Sorry, can you see the slide?
Slide is visible. It is showing green chemistry, the earlier one.
Yes, yes. Let me see the slide. It's freezing again. Okay, the next slide. Can you see this role of a polymer chemist?
Yes, yes.
Okay, the role of a polymer chemist. So green chemistry pocket guide, if you go to the ACS American Chemical Society handbook, then we'll get a pocket guide book also. So role of a polymer chemist is the 12 principles they have already given as a pocket, so that every chemistry or every polymer chemistry people can use this one. So number one, in a short way, though if you go for a green chemistry, it's already a subject. So it takes long hours to teach everything. But however, as 12 principles they prevent waste. Number one, atom economy. That is how much atoms we are using to create a polymer, and how much like atom economy is there is no waste of the atoms from this reactant to products. That means there should be less byproduct. So prevent waste, that we understand. Second one is the atom economy. Third one, less hazardous synthesis. While synthesis, if we make a very good product, also sometimes the way we are doing may not be good. Sometimes we are getting the best products, but the way we are making the products, the number of steps we are doing in getting the product may not be viable. That I say the people profit for it. So in that case also it may not be profitable for use or for as a business point of view. So that's why like design of benign chemicals, like less hazardous synthesis, design of benign chemicals, benign solvents and auxiliaries. Sometimes we can use the solvents, however the solvents should be benign. So benign solvents and auxiliaries, design for energy efficiency. While synthesizing or while designing the reaction, always have to take care of the energy efficiency. Later in the parts of recycling, I will go through this one, like energy efficiency. If it is not energy efficient, otherwise it the viable, whatever beautiful may the technology may be, it is not useful. So use of renewable feedstock, that we are doing this one, use of renewable feedstock, reduce the derivatives. If we are making a product from like reactant to products and we are making number of derivatives, then again of no use. So reduce derivatives, then catalysis, like try to use catalysts so that the reaction can be faster, energy consumption can be less. Lots of ways the catalysis is a very good subject topic of research. And then again, design for degradation, life cycle assessment, and real-time analysis for pollution prevention. And final one is the inherently benign chemistry for accident prevention. So green chemistry, if you go for definition, that's the design, development, and implementation of chemical products and processes that reduce or eliminate the use and generation of hazardous substances. So this is the basic thing of green chemistry. So coming to the next slide about the plastics, the production, use, and fate of all plastics ever made. If you go to the like history, like I've said, revisiting, I have given some idea about how we are living on this planet and what we need actually. But the actual scenario is what? Till this green chemistry point, in what way we should live on this earth, I have explained, for a sustainable living. Now we are going for the actual field. In what is happening in the actual field? So in the actual field, if we see that from the production of plastics, the production, use, and fate of all plastics ever made, that was a Science Advances Research article published in 2017. So see, we estimate that they have estimated that 8,300 million metric tons, not tons, there are million metric tons, as of virgin plastics have been produced to date. How much? 8,300 million metric tons of virgin plastics have been produced to date. And as of 2015, approximately 6,300 million metric tons of plastic waste have been generated. How much it is generated? 6,300 million metric tons. How much we have synthesized? 8,300 million. This is most of the plastic we have made them, like around them, they are not approximately waste. This is all, most of them are waste. Only around 9% have been recycled. 12% was incinerated and 79% was accumulated in the landfills or the natural environment. That means 79% is accumulated in the landfills or natural environments. 12% is incinerated or the burning, that we can say, or only 9% has been recycled. So if this current production and waste management trends continue, roughly 12,000 million metric tons of plastic waste will be in the landfills or in the natural environment by 2050. How much that is? 12,000 million metric tons, and it will be more than our, if you compare the oceans, then there will be more plastics in the oceans than the fishes or the aquatic animals. That will be the scenario by 2050. But it started like large scale production started only around 1950. How long it is? It's only around 70 years. If you go for the history of plastics, then it is around 110 years that the first plastic was discovered. But the thing is that by after 1950, the rapid, like large scale production was started. And after large scale production, it is only 70 years that we are reaching this 8,300 million metric tons of plastics, and we are generating waste of this 80% of this 8,300 million metric tons. So this way of living is not sustainable. This is a real thing. If you go for that is 2017 paper. If you go for the 2021 paper, this was published in December 2021 by Jean-Paul Lenz. He is also an entrepreneur, scientist, as well as he works for university, as well as for an industry, and around 30 years he has experience of working in plastic waste management. So see, he's written sorting, recycling, and disposal of product redesign. These three things: sorting, recycling, disposal, and product redesign. So thing is that now a little bit we can say that improved, since we are concerned about that. Earlier, if you go for all about waste, the world is producing 1.1 gigatons per annum of consumer waste. This is your municipal solid waste or MSW, with production varying from what is less than 1 kg per capita per day for low income countries. However, more than 2 kg for your high income countries. But your MSW typically contains what? 10 weight percent plastics. Okay, so now among this 10 weight percent, the 10 weight percent of plastics consist of mainly what? 60% of your mainly polyolefins. That means your high density polyethylene, STP, high density polyethylene, low density polyethylene. For the students, if there are any students that I say like PG students, I'll go through again what is HDP, LDP in a simpler way. But for now, it is like your high density polyethylene, low density polyethylene, linear low density polyethylene, LLDPE means linear low density polyethylene, and polypropylene. The remaining fraction being your PET, polyethylene terephthalate, PVC, polyvinyl chloride, PS, polystyrene, and minor polymers. So now the scenario is that what I was telling, that globally about it is slightly increased. In the last part, I have seen, we have shown that like yes, 9% around has been recycled, but you can see here slightly increase in 2021. Recycling rate is increasing. Globally, it is where about 12% of the spent plastic is recycled. So scenario is slightly better. So from 2017 to 2021, it was 9%. Now the recycling is 12%. So a large fraction is incinerated now. Is incineration percentage is also increasing. That is 25% is incinerated, but the bulk, that is 60%, ends up in the environment. So earlier 79% was ending up in the environment. Now 60% is ending up in the environment. The scenario seems a little bit better. However, because like European Union or the Green Deal, they have signed the Green Deal, which expires by 2050. They become to be climate neutral, or they will be entering to the circular economy. So there are some stringent rules given by that was like, or guidelines forwarded by European Union, or as well as in the US and other states, that is creating some better or that is moving towards circular economy or more environmental sustainability. But though we have this much of waste created, nature has always solutions. So what is the solution of these enormous amount of waste we are creating? So can we get any idea from nature's solution? Does nature has given us any idea for solution of this enormous amount of plastic waste? Yes, nature does not have design problem. You see that nature does not have design problem, but people do. If you see here, what you can see here, these are spider webs. These are orb spider webs. Why I have shown this slide? Because These spider webs, they are excellent polymers. They are made of protein, silk protein. However, they are excellent polymers. You can see every day this orb spider weaves the net, and where they will get the protein to weave the net, because this is made of silk protein. Where the orb spider gets the protein to weave the net every day, the solution is they ingest it 1/3 of the net. They ingest itself, recycle it, and makes again the next day the web. That is the recycle. They are recycling it. So we can get, and these silk fibers, if you go for the next slide, they are one of the most beautiful polymers. If you go for the property, of this spider silk, it is lighter than cotton, but stronger than steel. Thinner than a human hair. If you see that, thinner than a human hair, but handles loads of hundreds of times its size. It can handle hundreds of its, but it can handle the load 100 times more than its size. It can be woven into elaborate structures by mind, so that you know already. So chemists, metal scientists, and engineers are studying and trying to mimic these webs, mimic these silk and threads that spiders create, so that we can recycle every day. If you go for the property, again, it is a very good property that adhesive, strength, or other properties. If you go for, we can see that the significance here, if you compare the Kevlar, the latest words like specialty plastics of today's world, if you compare the Kevlar and the spider dragline silk, you can see here toughness property, stiffness you can see here. So strength rating 1.1 gigapascals, not as strong as Kevlar, because Kevlar is what? 3.6 megapascal. So strength rating is slightly lower than Kevlar, but tougher than the Kevlar. If you see the toughness property, then you will see that it is tougher than the Kevlar. So rigid spider silk has a toughness factor of 180 megajoules per meter compared to Kevlar's toughness. What is that? That is your 50 megajoules per meter. So compared to toughness, it is better than the Kevlar. Still, it is recyclable. Thing is that. So we humankind, or chemists or metals, and are trying to make or synthesize polymers which are recyclable, as well as they have property better than that we are using, better than today's world that we are using. Along with better properties, we also need recycling criteria or regenerating or renewability in every product. So thing is that there was one book, again, I am suggesting to read. This is a Plastic, a Toxic Love Story. She says it, a toxic love story. Susan Frankel, she is also a Pulitzer Award winning writer. So you can see here, this is plastic. This is your plastic chair. P for plastic chair. You can see here, this is comb. A is for your lighter that we are using every day, and then is your polyethylene blacks. Then is IV bags, bottle and bottle caps. You can see here that everything we are using in this world today, from morning bucket or sitting chair, starting from a sitting chair, comb, lighter, everything from your hospital. So hospital waste also are creating a large amount of waste. So everything are made of plastics. So we cannot like escape from these. So what is the solution? Because you cannot escape everyday life. We are now like we are in the habit of using plastics from morning to night, or from hospital to industry, from paint coatings, from decoration to everyday needs, from utensils, everywhere, from food packaging to industrial packaging. Everywhere, if you go or if you see minutely, from our sweater or from our your t-shirt to blankets, mosquito nets, or file cover, every day, everywhere we are using plastic. So the escaping is not so easier. So where is the solution? Solution is that innovate it for better. There's only one solution: innovate it for better using the green chemistry perspective. So if you revisit the history again from celluloid, it started from celluloid. So that's why it's called celluloid to toxic love story. It started from celluloid, that ivory, because we know earlier the ivory people used for comb and for buttons and for making all these kind of things. People used ivory. that was your elephant. That is extracted from elephant, no? So enormous, like large amount, like large number of elephants were killed for the ivory only. So with the increase of human population, we need that, like people need more ivory, which is not actually possible, because like initially when polymer development or the polymer was plastic world was started, it was actually to shape the nature, not to destroy the nature. It was like that, to save the nature, because there was a EPA, Environmental Protection Agency in USA, US EPA, as well as some other European countries also have stringent regulation. They have forwarded that time, given some guidelines for stringent regulation of your shaving the animals that are concerned about that. So that time, regulations was there. So that time, medicines company, they have declared that they will be giving $1,000 cash prize for people, for anyone who will give a material that has a comparable property with comparable or better property with ivory. So since ivory is very hard, like your white, very hard material, and it can be used for like buttons, combs, and several kind of uses, thousands of uses. So that's why if anyone gives material like as hard as this ivory, then he will give $1,000 prize. This medicine company will give $1,000 prize, and they will make billiard balls. So later, what happened by John Wesley Hyatt? He invented this celluloid first. What he did in response to that $1,000 prize. So what he did, he mixed nitric acid. This acid with cellulose. Cellulose is easily available, we know, it's abundant natural polymer. So cellulose, he mixed cellulose with nitric acid, then he made nitrocellulose. Common, that time it was there, this gun cotton, called gun cotton. So then again, to nitrocellulose, he add camphor. So common compound that we can get at our home. So like nitrocellulose and camphor, then he got celluloid. That compound was called celluloid. This has such a wonderful property that this material invented by Hyatt in 1868 for munitions company to make billiard balls, like sports, for a sporting material, later revolutionized the motion picture, photographic film. Edison discovered the motion picture and revolutionized the celluloid industry, that is cinematic industry. Now we know cinema industry, but Edison's discovery was enhanced by discovery of this celluloid only, this product, Hyatt's product. Otherwise, it was impossible, because that time people were using glass plates. Glass plates were very brittle. So when it fell down, it breaks. So very brittle, one thing. Other was that it has higher weight. So due to these two reasons, it was very difficult. Again, it was not flexible enough. So it is difficult to make motion picture, utilized in the motion picture, or difficult to handle. So discovery of this celluloid has revolutionized the motion picture industry, or the photographic film. Photographic film was replaced by this material, and cellulose industry was developed, revolutionized later. Now, this was cellulose was the natural ingredient it was used. So it was partially, we can say, not a purely or totally 100% synthetic plastic. But if we go for 100% synthetic plastic, all from then, we can say that we can date back to 1909, when the Leo Baekeland, for his own General Bakelite company, he developed this in response to shellac. That time shellac was there. Shellac is a gum resin. It's a natural gum resin, and which was utilized for as a insulating material. That time, again, we go for the Edison's days. Thomas Alva Edison, scientist, and then Nikola Tesla. There was a revolutionizing about when the electric bulb was discovered, because after the discovery of the electric bulb by Thomas Alva Edison, parallelly, Nikola Tesla was also working, and there was a current war at that time. There's a good movie about current wars, about Nikola Tesla and Edison. So forget about that. But thing is that when it was discovered, there was need of rapid electrification in the country, in the US. So thing is that for rapid electrification, they need lots of insulating material, which cannot be possible by using the shellac. So the meeting the need was not possible by natural gas. So that time, this was Leo Baekeland has given this solution, and this was used as a insulating material initially for electrification. But later, the material has like a shellac was replaced by bakelite, but this bakelite material has lots of uses. We can use for different things. This bakeland has around 400 patents for its uses and synthetic methods. So the material is sometimes called, that's why material for 1,000 uses. We can use in thousands of applications. So it revolutionized the electrification as insulating material. So in that Time magazine 1950, they always give some like voting about what is the beautiful word, most beautiful English word, like most beautiful English word. That time, have a guess? What are the most beautiful English word in 1950 in the 10 decades from 40 to 50? Mother, memory. One was the mother, one was the memory, and we will be surprised that third was the celluloid. Celluloid was one of the most beautiful English word from 1940. So how much popularity of this material we can see here? How much popularity or how much the useful these materials were when they were initially discovered, or how much applications they have covered when they have initially discovered. So now the thing is that since it was discovered to protect nature, it was discovered since initially it was discovered to protect elephant, it was discovered to protect the shellac like rapid destruction of the plants, this shellac regina, the plants. But the thing is that now where we are moving, since I've already said about we have created enormous amount of waste. So there are also like recent trends in India to make some biodegradable plastics. The first always comes about biodegradable plastics. However, the word is not so, by making a biodegradable plastic is not so a easy one. People are working, and we hope by 2050 we'll be getting lots of biodegradable solution about biodegradability. So plastic roads, still there are like in the lots of fields biodegradable plastics are entering, but there is always like benefits are always high, the higher benefits are there, but there's always like about the thing is that about the business, I have said people profit planet. If we think that, then from the business point of view, there if we cannot develop a more profitable, then again there always it will only be a discovery only, there will be no application or no use. So that's why in both the cases, all three cases, we have to take care. So second one is the plastic roads. This is reality. So with an aim to overcome the growing problem of plastic waste disposal in India, the Plastic Man of India, we know about this one, the news was there around 5-6 years back. Chemistry professor Rajagopalan Vasudevan at your Chennai developed this technology to build Indian roads by plastics. So road made of plastic composite have better weathering resistance than standard asphalt concrete roads. So these roads do not absorb water and have better flexibility, which results in less routing and need of less repair. There are also success stories in India. We have written one article, I will show you later, utilization of plastic waste and its technologies, an overview, written by me and Aranjula Kicho of NIT Nagaland. So there we have shared some of the Indian scenario, the success story of Gujarat. So co-processing of plastic, that was one of the success story, and there's a beautiful story, you know, using of waste plastic materials as an alternate fuel or raw material. What they did, they did waste plastic material as an alternate for fuel or raw material for industrial process such as cement plants known as co-processing. So the advantage is about this technology is that it can substitute the use of coal and petroleum in the industries like cement plants. So a collaborative work between Gujarat Pollution Control Board, GPCB, then recycled paper-based industries and cement industries in Gujarat succeeded in having a scientific solution, a scientific solution of utilizing this technology by designing in a new way. So what they did, this collaborating work of Gujarat Pollution Control Board, recycled paper-based industries and cement industries in Gujarat. So what they did like the good news is that the paper mills, because they generate a lots of enormous plastic waste. Paper mills, like because like recycled based paper mills, no, because there is a coating always there in paper. There are lots of coating, no, in books and covers there are lots of plastic coating is there. When you take out this one, then they will generate lots of plastic wastes. So because they are recycled, there are lots of recycled paper based industries in Gujarat. They are recycled paper based industries, so they will generate lots of plastic wastes. So these enormous plastic waste generated, they were used by cement plants. Okay, how the cement plants use this plastic waste? The plastic waste they collected and they used in cement plants as a fuel. So this waste plastic can be used as a fuel. So they have saved the money in this way. In one way, they have saved the petrol or diesel or fuel price or the cost of the fuel. They have saved. The cement industries have saved the fuel cost, as well as the recycled paper-based industries got rid of what? Their enormous plastic waste. So this was a win-win situation. We can call it win-win-win, three-way. One is from recycled paper-based industries. They had got rid of the plastic waste. Number one win. Second win was the cement-based industry in Gujarat. They have reduced the cost of the fuel. Second win. Third one is the win in the sense of sustainability. So that this was a win-win-win situation. The good news is that if you do one good thing, then it spreads. The good news is that in 2012, Gujarat's success story encouraged neighboring Rajasthan to utilize the paper waste plastic-based technology as a thermal substitute for cement kilns and promoted circular economy and the overall reduction of pollution. So it was spread to Rajasthan and other parts of the Indian states. So these are the success stories that in India also people are doing. So people are also working on mechanical recycling along with this. These are the chemical recycling techniques. Along with this, also people are using some chemical recycling methods. So overall, if you go for plastic waste management scenario, what are the options we can do? I'm saying about mechanical, I'm saying about chemical recycling, I'm saying about the overall use as a fuel material, and then options and prioritizing. If you go for what are the options and how we prioritize a plastic, in which way, or the waste plastic, in which way we want to go, considering the waste plastics or plastic waste management. So depending first is the quality or purity of the waste. To go that, like, what is the quality or purity of the waste? First thing is that we have to consider this. So depending on that, so priority should be always given. Number one, reuse. Number one, always priority is given for reuse. Number one. Number two, reprocessing. Number two is reprocessing. That is your mechanical recycling. Number three is depolymerization to monomer. So what is number three? Number three is depolymerization to monomer. Number four, conversion to a hydrocarbon feedstock. If it cannot be converted to monomer, then go for conversion to a hydrocarbon feedstock. Number five, energy recovery. So this is the hierarchy. Sometimes it is called the hierarchy. Let me switch on the fan. So if you go for the, depending on the purity of the waste, we'll go for the hierarchy level. Then number one will be reuse, then reprocessing, we can call it a mechanical recycling. Third one, depolymerization of the monomer. We can make monomer by chemical way. However, I've said already this, we have to take care about, is it viable? How much energy it's consuming while depolymerizing? That is always a point of concern, because most of the polymers, some of the polymers can be made monomer, like your nylon. Some others are there. I will show you again which polymers can be depolymerizable. However, there would always be like how much steps you are going and how much energy you are utilizing while depolymerizing it. That's why it is always your third option. Then conversion to a hydrocarbon feedstock, and finally energy recovery. So this is called waste hierarchy. So where it aims, waste hierarchy always aims at maximizing the value of the product of recycling. Number one, maximizing the value of the product of recycling. Number 2, minimizing the waste of energy and material along the full cycle. So minimizing the waste of energy and material along the full cycle. Number 1, maximizing the value of the product. Always it aims on these two. So this paper published in 2021 in the last December, you can see that here the prioritizing they have given. We can speak about recycling, mechanical, we can speak about depolymerization, we can speak about pyrolysis. When about pyrolysis, this is thermal crack. Earlier also pyrolysis was used, this thermal crackdown in our petroleum industry. There is not a new technology. Pyrolysis is a very old technology. It was already used in petroleum industries for cracking down or thermal cracking of the crude oils. This technology, same technology can be used in waste plastics to breaking down to smaller components. So then depolymerization, you can see here, but how much waste it is creating. Waste wise, we can see here like spent product. This is your spent product energy. If you see here, then we see here cracking higher than polymer. So always your utilization is the better method than your mechanical recycling. Go for reprocessing or transfer, this is called, then depolymerization, then cracking. So this is actually last option, then energy recovery, last one. So if you go for plastic waste quality now, so depending on the quality, always decision is taken. So what is the waste quality? So post-consumer plastic is intrinsically heterogeneous. We all know that there's always intrinsically heterogeneous, mixed of undefined quality. We don't know about the quality. We don't know how much plastics are there. We don't know that the blends or cross-linked, what kind of polymer is there. So it consists of variety of plastic items that are made of variety of polymers. But mainly in post-consumer plastic, what we get the polymers are polyethylene, polypropylene, and PET, and often certain amounts of foreign materials like foreign polymers, additives, and other contaminants. For instance, if you go for like bottles, like plastic bottles, trays, there are some films, and also there are some like residue and additives. These are also there, the foreign materials. So overall, what is that have been shown that you can see that 75 to 90% is dominant polymer. What is that? 75 to 90% is dominant polymer. Dominant means the main polymer that made the plastic bottle or your whatever the good may be. So 75 to 90% is the dominant polymer, that is polyethylene, polypropylene, PET, or polystyrene. These four. These among the big six, these are the four: polyethylene, polypropylene, PET, and then polystyrene. So the remaining 5 to 15% is foreign polymer and paper. Also, there are some papers and foreign polymers are there, because to strengthen or sometimes to insert some or create some new property, sometimes foreign polymers are also given, or sometimes as a indifferent to make it flexible, to harden it in different ways. Sometimes like to give some new value added property, foreign polymers are added, and paper, and 5 to 8% of residue. So the foreign material and the residue were mainly the point of concern. Can you see the slide or not? Is it visible?
No, ma'am.
No. I think I have to share it again. So let me share it again.
Now
is it visible now? Yes. Okay, so depending on the quality, the material heterogeneity is ever larger multi-layered frames. If you go for multi-layered frames, again the heterogeneity is increasing. 55, sometimes only 55% is the bulk polymer, that is the main polymer. So now, if you go for, first thing is the sorting. How to sort out these plastic wastes. Sorting of the waste is the main basic criteria. So for sorting, there are 3 or 4 basic things are there we can do for this. Is also not a very big problem. So nowadays, because there are a number of solutions are there, we can prioritize them and we can use one by one. The plastic sorting, the first one is we can go is an air classifier. You see, feed goes from this way. The heterogeneous feed goes from this way. Air stream is flown from this way. You will see light will go up and the heavy will go down. In this way also, mainly for the roughly, this is done. In the second step, if you go for like second method is the sorting of like sink plot sorting. Very like easy technology, that is your sink plot. It depends on density or specific gravity, we can say density. If the density is higher, it will sink based on water density. So if the density is higher, it will sink. If the density is lower, it will float. So we can separate them, segregate them according to the density. So lower density polymers are which are the light colored. You can see here lower density are polypropylene, STP, LDP. Once you sort out in this way, you can say that lower density are, that means polymer plastics which are floated, they are polypropylene, SDP, LDP, and then plastics which are sinked, they are PVC. Possibility is that PVC, PET, and ABS. ABS is acrylonitrile butadiene styrene. PET we know polyethylene terephthalate, polyvinyl chloride. Polypropylene, high density polyethylene, low density polyethylene. So once we segregate by float and sink method, we can segregate at least some of the polymers. This group has polypropylene, SDP, LDP. This group has PVC, PET, ABS of the municipal polymer waste. Okay, then coming to the, once it is segregated, again for if there are any ferrous materials, if the additives are added, then we can go again that we can segregate them or we can sort them. If there's any ferrous material or ferrous contaminant or iron type material or some metals are there in your waste plastic, then what we can do? We can feed waste. You can come here, you can like add here, then magnetic pulley is there. Then this is called magnetic sorting of ferrous metal, magnetic sorting. Then this is magnetic head pulley is there. It will move. What happens? This is a conveyor belt. What happens? This magnetic particles will go to this cup and non-magnetic. This is your particle will go here. That means your non-ferrous will go here. Magnetic particles will go here. Non-magnetic particles will go here. In this way, we can separate some magnetic like ferrous metals. This is called magnetic sorting. So ferrous metals we can separate. Fourth one option is there again one, that is what? Sensor-based sorting. In the sensor-based, this is the feed waste. We can add here. There will be sensor and air gun. We can also material 1 and 2. According to the sensor, we can use different sensors like your UV, IR, and different ways are there. That you can X-ray technology is also there nowadays, that you can detect metals. Metal detectors are there, no? We already know. So according to that, we can separate different ways. There are also German-based ways are there, like DKR plastic fractions. They are called it DKR. So if you go through this paper, then you can get that like your WR 2017. You will see that collected plastic waste, they can screening, sorting, then the film DKR 310, DKR 329. There are different your methods or different guidelines are there, and you can separate a different way after once you reach this point. Now, however, if you go to the overall, like once sorting is done, sometimes we need rough sorting only, because for HDP, polyethylene, polypropylene, sometimes they can be mixed and they can be doing a mechanical recycling way. Main thing is how much value you can add to them. So according to them, or how much like valuable product you can get them. So all the, according to the priority wise, we have to, after sorting, we need a pure polymer or not. That also depends. Sometimes PP, HDP, or that I have said that PP, HDP or LDP, that can be taken together, and because if they are showing the similar property, then you can blend them. So depends on what product we want to get. So fat of plastic. So most of the fat of plastic is that once of the plastic waste. First we sort them, then sometimes it's manual sorting and sometimes it's mechanical sorting that I've shown the ways. So manual sorting and mechanical sorting. Then if you go for washing, once it is sorting, washing is done. Washing is done mainly by caustic wash or detergents or organic solvents, or sometimes for dry cleaning also, if it is a high valued product. And third, we can go for mechanical recycling. But however, for though it is a very preferable technique, and sometimes no need to segregate all the plastics. Plastics with similar property we can take together and mechanically recycle. But thing is that always have to take care is how many times we can recycle it. How many times it can resist, because sometimes the property deteriorates in every recycling cycle. So how many times, this is also always a point of concern. Every polymer has different recycling, sometimes called as polypropylene is at 4 or 5 times. However, in practice, 1 or 2 times we have seen that it's having good property. But for fourth one is the polymer recovery. Recovery is also one of the good step, like dissolution and precipitation. This is a simple method: solvent, anti-solvent. By using solvent, say this is a mix of polymer, like we have initially sorting by this density method is very easy and very low cost. No cost requirement is there, capital cost requirement. So after segregating or sorting from density requirement, then we can go for dissolution, like precipitation or like that. For that, if a solvent is used for a particular polymer, I want to extract from a mixed waste, I want to extract a particular polymer. Then what we do, I will dissolve the solvent in a solvent of that polymer. It will dissolve it once, so that it will dissolve only that polymer, not the other polymers. Once it dissolves, then I will add some anti-solvent of the polymer. Then it will again precipitate. So that is called dissolution, precipitation. I can take the pure polymer in that way. The solvent, anti-solvent, polymer recovery, we can recover in a very good way, very in a pure way, like pure polymer we can get by this dissolution, precipitation method. However, there is involvement of lots of solvent. That I have already said, in the green chemistry perspective, we have to think there is a involvement of lots of particular solvents and anti-solvent. However, there is again solution. If we can recover the solvent and reuse the solvent, then this method is very viable. So this is one thing. However, another thing is, they are more additionally, while recovering, we can recover by rotary evaporator sometimes by some other way. But the thing is that while recovering, we have to always take care that how much energy it is taking. Because while recovering solvent means we have to dry it up, then distill it, then another beaker. Distillation steps are there. So how much energy the solvent, the particular solvent or the particular anti-solvent is taking while recovering, that have to again check and care. Though it's a very good method. Fourth one is the chemical recycling. If it does not go through this mechanical or polymer recovery, we can go for chemical recycling. One of the beautiful methods, monomer and other product recovery. We can recover the monomer from polymer by depolymerizing, or other products, sometimes the derivatives or some valuable products, not only monomer, sometimes we can also make some other valuable products. There's also pyrolysis method in it, and there's also alternative chemical valorization. Energy recovery can be done, fuel recovery can be done. These all methods comes under chemical recycling. These methods are specifically one by one method are very important and very needs a closer look, needs a closer research to make one by one, case by case, for a valorization or to make a technology practical way, in a practical way to come to the field, needs a closer look or a closer research in every way. This is a overall discussion only. So sixth one, we have given biodegradation. It can go up to the one also. Biodegradation is always preferable, but however, I have given from practical point of view. However, how much biodegradation we can add to the polymers is still a question. Some are adding. However, how much biodegradation we can add? Incineration is one of the option. If all the ways are not possible, then incineration is also a possible option, because the energy we get from incineration can be utilized for other works. Landfill is the last option. That should not be chosen, but that is the last option. If you go for the which way or which we can choose, just for a overall, I have said that if the energy requirement is very high, then it is not a suitable. Say nylon 6 is very good. We know about ring opening polymerization of nylon 6. That we can be, this way we can see the addition polymers, these reds are, and this green are condensation polymers. So nylon 6, it can easily depolymerize. The rate is around 70 to 80% yield, very good. But we always have to, and most of the nylons are recovered also. But the thing is that we have always to take care. Nylon 6 is the same case. We can see here polyurethane, PET, mostly recyclable. They are recycled also. Epoxy, very less. If you go for PP again, energy requirement is there. I have said that PP is very good, we can recover, but however, energy requirement, PVA, energy requirements, polyethylene, PVC, you see here, almost not done. Because we have to go for Dale HF polymerization. Energy requirement, how much energy it is consuming, how much it is consuming for depolymerizing. So always we have to take care. Will we go for reuse? Will we go for mechanical recycling? Or will we go for, if possible, will we go for depolymerization? Though there are lots of possibilities, however, there is always need for new synthetic methods or new depolymerization methods so that it can consume less. However, if we calculate the bond energy or the enthalpy, we can see that some polymers are still depolymerizing is practically impossible. Theoretically possible, but practically impossible because that takes lots of energy while depolymerizing step. So we have also written one article on utilization of plastic waste and its technologies, an overview. Last year it was published in 2021. So Aranjingla Kichu, who was working in DST project at NIT Nagaland under my supervision. So most of the work was done by her. She was a ZRF in the project. So the global scenario, we have emphasized mainly on Indian scenario, plastic waste generation, what Indian scenario, and we have covered the co-processing that I have said, the co-processing of cement plants, and then current scenario is what in like Indian and like world scenario. Simply the paper was written and the mechanical and chemical recycling overall topics were covered, not for a research or it was a book chapter like article. So overall idea was given. Also in the plastic waste management in modern approaches, I have said about now about mostly I have discussed mechanical and chemical. However, in modern approaches, there are some plasma assisted pyrolysis methods are there. These methods are there. Some other techniques are also there, which are very good. Like modern approaches are there, which can be utilized, but they are still in research stage, or maybe they are very good step, but they are not coming to the market due to the cost and the energy consumption reasons. So the next part, I think we have 15 minutes. So let me quickly go to this LDP, HDP. I have already said about this is the structure of LDP and HDP. I think no need to go. So however, they are used in milk jugs. We can segregate them. How we can segregate them? We can segregate them according to the where they are used or according to the recycling number. So in the big six, there's polystyrene, LDP, HDP, I have said already. So all this goes to the plastic wastes. So PP is there, polypropylene, then PET. These are the main big six polymers. Now the thing is that do we want to do this maths? A single polymer molecule of high density polyethylene is found to contain 15,000 ethylene units. What is the mass of the polymer? Simple math. Do you want to do this for a warm up only? I'm speaking from one side. So from participant sides, do you want to do this math? For recharging? A single polymer molecule of high density polyethylene is found to contain 15,000 ethylene units. What is the mass of the polymer molecule? The mass is molar mass of ethylene. We know 28 gram per mole. We know already what is molar mass of ethylene, 28 gram per mole. Then mass of polymer will be 15,000 into 28. This will be 4.780 gram per mole. So in this way, just multiply the molar mass by the ethylene or the monomer units, then we'll get the mass of polymer. However, different polymers have different, same polymer have different molecular mass sometimes. We can get the example of PVA, polyvinyl alcohol, we'll say like low molecular weight PVA, medium molecular weight PVA, high molecular weight PBA, they all will have again different. We know that PBA is soluble in water, but if we take high molecular weight PBA, it is really in the 1 week, you cannot solubilize in water. That's the thing. So by changing the molecular weight, we can change the polymer properties. So there are also lots of questions I'm not going to discuss, I think, because we are running over time. Around 10-15 minutes are there, I think. So can you do this math? A polymer with representative formula of CH2, CHSG. SG means side group. CH2, CHSG. There's a degree of polymerization 500. What is the degree of polymerization? That means monomer unit 500. Then what is the molecular weight? Total molecular weight is 26,500. Identify the monomer. Side group is for SG is for side group. Can you identify the monomer? Can anyone identify the monomer? Degree of polymerization 500. Molecular weight 26,500. Okay, this will be your acrylonitrile. This is CN group. Side group will be CN nitrile group. Because if you, this is the molecular weight, the number of monomer is your given, your polymerization degree of polymerization is given 500. If you divide it, then you will get the molecular weight of the monomer. Then from the molecular weight of the monomer, you can calculate it. Fine. So if you go for rethinking, what makes all the differences in the same polymer? Same polymer sometimes like PVC. PVC is sometimes very rigid, sometimes very flexible. We can use in the flexible pipe as well as we can use in the plumbing pipe. Very hard. From very hard to very flexible, we can use the PVC. The same way polyurethane, we can use the flexible as well as for a hard material. Polystyrene, we can use as a CD case very hard, sometimes as a polystyrene foam, which are very foamy. So lots of things are there within a polymer. What makes them? That makes them different properties. Though the polymer is same, they are having different properties. So there are, these all are due to the arrangement of monomer chain. One is the arrangement, end-to-end arrangement, or head to tail, tail to head. This way, the arrangement or the plasticizers. Plasticizers can be added to a polymer to make it more flexible. We can add plasticizers to make them more flexible. The PVC is done the same way. But the thing is that this is the main culprit, how to take out the plasticizer. Again, if you go for consideration of waste management, then the how to take out the plasticizer. Sometimes the polymer may not be as bad as we are thinking because they are totally unreactive. All the LDPs, HDPs, PVCs, they are almost unreactive in our room temperature. So what is the problem? They are unreactive. They are not soluble in most of the solvent that we are using. Then what is the problem? Problem is the plasticizer that we are using in the polymer. So that we have to take care. There is a way, like there is a very big field. Can we change the plasticizers? Can we make the not only the plastics? Can we change the plasticizers? Can we use some green plasticizers? Can we use some comparatively green plasticizers, or can we innovate the plasticizers, new plasticizers that are more eco-friendly and will add sustainability to the polymers? That is also a very good field. So we know about polyesters, dacrons, polymers that we have already discussed. So now the diversified use of plastics we have seen, the diversified use. Then we have also went for sorting and all this. So how to identify them for sorting? We can also go for manual identification. If we go for manual identification, then we can identify them like number 1, because there is always this recycling number is given. These are the symbols, and recycling number is given on the back. We will see in any bottles or milk jugs, because there is a guideline. So according to the guideline, the recycling number is given. And number 1 is for PET, so that we can sort them by ourselves, or it makes manual sorting very easier for recycling. So number 1 is for PET, polyethylene terephthalate. Number 2 is for high density polyethylene. common white, this you can say HDP high density polyethylene is used in your shampoo bottles, milk containers. You can see shampoo bottles and milk containers. In the Western countries, they are mostly used in milk containers. This is high density polyethylene. Number 2. Number 3 is very hard, rigid, clear plastic, such as your cordial bottles. We can see here, like this is V. This is your PVC, polyvinyl chloride. Then again LDP, low density polyethylene. Number 4, low density polyethylene. Number 5, polypropylene. Number 6, polystyrene. And number 7 is the mixture. In this way, we can segregate manually also by seeing the recycling number. So where do they go after use? I have already discussed about most of them goes to the landfilling, then incineration, and then recycling. So municipal solid waste, if we see the US scenario, we'll see that they are still US are using, though the EPA has set out some of the hierarchy of methods, however, they are not recycling all the municipal solid plastics. So if we see that, it should be noted that US has long way to go in recycling plastics. Sweden recycles what? 80% of the plastics they use. How much? Hello. Sweden is always highest in recycling. Yes. Yes. So Sweden recycles 80% of the plastics they use. US recycles 20%. How much we recycle in India? Do you have any idea how much we recycle? So I think we'll not go for composting and biodegradation. So I'll just give a brief idea on what we are doing. I've given the overall plastic waste scenario and how people are utilizing, how the modern countries are, how the developed countries are utilizing these technologies, and what we are doing a simple way. We are doing some of the simple mechanical methods, and we focus on wood polymer composites, some plant oil-based resins, and then some other polyparaphenyl diamine-based hybrid nanocomposites. I will give a simple, I think we are having some 5 minutes now. So a simple idea about what we are doing. So this baseline data was collected from Sumukidima and IT Nagaland there, and there's lots of furniture, wood and furniture industries there. So we have collected the neem, mostly they are using 2 types of woods, neem and teak. So teak is a valuable, and neem is also like have low cost. So we collected some neem powders, this dust, wood dust, and then we combined them with waste plastics. So these were the recycled plastics and wood flour, and we added some additives and made some this panel like wood polymer composites. So the recipe was just a simple, and this was a polymer blend. You can see polymer blend with weight ratio of SDP, LDP, PP, and PVC chosen. The ratio we have chosen was 1:1.5 because this is the most common ratio that is found in municipal plastic wastes, so that we can do it without sorting, so that we can make them without sorting. That's why we have made this ratio of HDP, LDP, polypropylene, and PVC. So of these 4 polymers, then we have used C5, like a 5 PHR of polyethylene polyethylene grafted glycidyl methacrylate. Polyethylene grafted glycidyl methacrylate we have used. This is G5. These all are in PHR, parts per 100 of rubber. Then PB G5 W40 means wood flour. That's a neem wood flour, 40 PHR. C2 means clay. We also use some nano clay. So this 40 PHR of wood dust, and then PB is for polymer blend, then wood dust, and combined with clay and titanium dioxide. And we can see here the improvement in property. First, the treatment of wood dust and plastics. The wood dust was treated, they cleaned and dried and modified. Then TiO2 nanoparticles were synthesized. Then after like synthesizing of TiO2 nanoparticles, then one sheet like this way, the composite sheets were obtained by compression molding. This way, the composite sheets were obtained. And then you can see here the sheets. Then you can see here water uptake studies we carried out, and finally chemical reaction test, and finally the mechanical property was mostly improved. We can see here the improvement of mechanical property was seen in this particular product, this one, 5 PB G5 W40 C2T2. Polymer blend G5, then W40, clay, 40% of wood flour was there, and it shows higher good properties compared to other polymer blends. And this work was done by Vamsi Narathi Ratnam. He was master's student of BSMS Material Science, now working in a plastic industry in Hyderabad. So he worked most of these parts as his MS thesis. And these are the strips that you can see he has made. So wood polymer composites and shows some good property. Later, he also worked for how can you make for transparent wood composites. These were the composites. Once the composites were made, they were again compressed to make sheets. So these are the some TEM and SEM studies that he has carried out. And you can see here beautiful, like reusable. You can use them as for some panels or as some construction materials. He also made some transparent WPCs so that they can be used in solar panels. And other work was on neem. Since we are using neem flower, we are also using and then extracted oils from trees grown in Cheris High Academy, Chumkedima, Nagaland. The seeds were collected, and then your oil was extracted. By oil extraction was purified. Once the oil was extracted, it was purified by column chromatography technique over silica gel 60 to 180 mAs using a mixture of 90% hexane and 10% ethyl acetate as a eluent. So TLC was done to check whether it's purified or not. But the thing is that the solvent removal was carried out. We have not wasted the solvent. We have recovered the solvent by using rotary vacuum evaporator, and it was reused. So if you see the physical chemical property of neem seed oil, we can see here, and it was used for this was the fatty acid composition by GCMS, gas chromatography mass spectroscopy analysis, and this was used for making the resins. You can see here the resins made from neem seed oils, and these resins were, this was the reactor. It was stirred by mechanical stirring. It was carried out, and around 210 temperature, you can say 220 temperature. Lead monoxide was commonly used, but we have used sodium hydroxide as a catalyst because we wanted to use some benign catalyst. So using sodium hydroxide as well as some nanoparticle, copper oxide nanoparticles we have used. And you can see here, like the reaction time was decreasing. It's a plot of acid value. Acid value was continuously decreasing. That means the polymerization reaction was going like in progress. You can see here the number average molecular weight of neem seed oil and weight average. You can see here. This is for neem seed oil, 967 gram per mole. Resin A, B, C, and D. You can see here continuously increasing the molecular weight, showing that the oil is polymerizing to give resins. The resins were then analyzed and cured and made some films. The same way, the resins were again, the water contact angle was measured so that it can be used for some marine, because our target was to use as a anti-corrosive coating for marine vessel applications. So that's why water contact angle was measured, and we have seen that water contact angle was highest in resin D. Again, the same thing was, this was the corrosion study. You can see uncoated panel, coated panel, and cut coated. We have cut for N, we put N, and then we have tested for corrosion study. You can see this is the before immersion. It's an uncoated panel. This is uncoated panel after 4th day. This is after 6th day. The corrosion was heavy, corrosion was there. But for coated panel, very less corrosion was there. So we were almost confirmed that this resin can be used for anti-corrosive coating. Ms. Parinita is doing PhD still now. She has done this preliminary part of work under Northeastern Council NHG project, and she has published some work in 2021 last year about the anti-corrosive coating. She also prepared some copper oxide nanoparticle to like reduce the time of reaction. You can see here beautiful copper oxide nanoparticles, and the size, dynamic light scattering shows that the size of the particles was around your 200 nanometer, and these particles were also used, and we saw that degree of polymerization increased. You can see here degree of polymerization, DP, increased with adding of copper oxide nanoparticles. This is 20 mC. So finally, molecular weight, you can see here, molecular weight also increased. So finally, copper oxide it was confirmed that copper oxide nanoparticle can be a good co-catalyst along with the sodium hydroxide catalyst. Again, the water contact angle measurement was done and compared with other resins. You can see here water contact angle was increasing from 72 to 94 and 102. Here you can see 72, 81, 94, because this is the same. This NR was taken, this resin A, then BCD, which is with seed oil. Then you can see here that water contact angle was getting better. Then again, corrosion study was done with this. You can say this is a paint coated panel. Asian paints we have used for coating for comparison, so that how it is working with the paints in the market. You can see here this paint coated panel. Then you can see a resin coated panel. It shows improved property. So we are go for MDGs to SDGs by we will be able how we can go for Millennium Development Goal to Sustainable Development Goal by 2030. So our role will be design for recycling and closing the cycle. So think globally. We believe in think globally, act globally. In Assam, we can see CIPET, PWMC doing a lot of work in plastic waste management. We have also a GMC commission, is working on this recycling techniques and how it can be utilized for waste management. And then again, Partha Pratim Pathak, he's a very prominent entrepreneur and he's a managing director of Fresh Air Waste Management Service Private Limited. He is working on biomedical waste. He collects waste from different hospitals of Assam, from GNRC to GMC, and then he treats the biomedical waste. He was one of the nationally awarded entrepreneur from Assam. And we think that there is no limit to the amount of good we can do if we don't care who gets the credit. So that is a takeaway home for today's lecture. We continuously strive for learning, unlearning, and relearning. Above all, we want to stay hungry and stay foolish so that we can develop something better for the plastic waste management. I sincerely acknowledge the SEED Division DST for their generous funding and CSI New Delhi, also for NEC, Shillong, NIT Nagaland, CIPET Jaipur, and Dona Institute of Assam. And we hope that plastic waste management is possible. Thank you so much for your presence hearing. And if you have any questions, I'll be happy to answer them.
Thank you very much, ma'am. Now the session is open for interaction. We have online as well as offline participants also.
Yes.
So they have many queries from the offline participants. So
I'm here, if there's query, they can speak out, they can unmute, and then.
Good afternoon, ma'am.
Good
I am
afternoon.
Pandit from USTM. Ma'am,
Yes.
I would like to ask about the fiber resins. How these fiber resins are actually made. After making the polymer, how these fibers are reinforced. Is it actually, are we actually mixing the fiber with the molded resin, or are we trapping this fiber in the polymer matrices?
No. Thing is like that. The polymer compound is made initially. Initially, the first thing is that first the wood these fibers you just collect them, then treat them, clean them and treat them, and dry them and keep them aside. One part. Second part is that you take the mixture of polymers, PP, HDPE, polypropylene, whatever you want to choose. You take you collect them, again clean them, wash them, and then dry. After drying, you just we have just used some solvents to mix them. Then you give some temperature around, mostly depending on your polymer. You have to know what polymer is there in your composition. So according to that, you have to increase the temperature along with the solvent. So go on for mechanical stirring. If you go for mechanical stirring, then you will get that around 2 or 2.5 hours, they will be mixed. Once they are mixed, you add the treated wood fiber while mixing and do it by mechanical recycling. Once they all are mixed, take it out, dry them, you will get some, then again you just grind them, you will get some powder like product. That powder like product you go for molding. Molding is the final step. Mechanical molding is the final step.
Ma'am, if molding is made, then we can mix the fiber after molding also, no?
After molding, how can you make the fiber? We are using wood fiber. What fiber you are talking about? Can you explain it? What fiber? Like you are talking about polymer fiber or about wood fiber?
Like, ma'am, glass fiber, jute fiber, or coconut fiber.
Yes, glass fiber. After molding, how can you add? After molding, you are giving the shape. Molding means you are giving the final shape. In the molding stage, you can give sometimes. In the molding stage, depending on the what kind of molding instrument you are using. This is a compression molding. So how can you add while you are after molding? It is dried. No, molding means you are giving some temperature and pressure, and you are pressing it. You are giving some shape. So after molding, it's not possible to add because it's already final product. That's the final stage. You have to add the wood fiber before that.
Ma'am, when biopolymer resins are made,
Yes.
whether styrene is needed or not for making the curing
Biopolymer,
process?
styrene. No need. You can use styrene. Fine. Oh no, what is styrene or styrene? What can you tell me the word again?
Styrene, ma'am.
Monomer, styrene monomer. Am I right?
Yes, ma'am.
Okay. You are making biopolymer resin. Styrene is not necessary criteria. We are not using styrene at all. Styrene sometimes uses a diluent. That is different thing. Sometimes it's a diluent, sometimes it's a for a monomer constituent also. But no need, I think, not necessary to use a styrene. Without using like zero styrene, you can make a resin.
Ma'am, those who want to make non-biopolymer resin, they will need or not?
Non-biopolymer. Repeat it again. Non-biopolymer resin. That means synthetic resin.
Yes, ma'am. Synthetic resin.
Yes. What is your question?
Ma'am, suppose someone want to make a thermoset polymer resin, they will need this styrene or not for cross-linking?
No. You can like use any kind of cross-linker. No need of using styrene all the time. Who has said you that styrene is used all the time? No. Styrene is only sometimes used. But without styrene, you can use like for cross-linking. You can use some natural cross-linkers are there. Mostly synthetic cross-linkers are used. There are synthetic cross-linkers are there. You can use them. You can use like your cobalt octet accelerator are there. Not only the cross-linker, there are some accelerator which accelerate the reaction. Once you enter in the field, then only you will see that lots of availability options are there. Styrene, you forget about that. That is an old one. But thing is that it has very good property because it along with the sometimes for cross-linking it also uses a diluent. But thing is that there is varieties of cross-linkers that you can use in in addition to styrene or without styrene, like you can omit the styrene. You can use another like cobalt octet, like accelerator is there, hardener is there, polyamide are there. Lots of like your cross-linker options are there. Once you enter in the field, you will see that lots of available options are there.
Okay.
Styrene is not necessary. Is it okay? Fine.
There is another question from.
Okay.
Good morning, ma'am. Thanks a lot for being here
Good morning.
and for sharing your valuable knowledge with us. Ma'am, I would like to ask you about the nanocomposite. Is there any kind of nanocomposite material which we use it for degradation in wastewater, ma'am? Actually, what is the PNC's absorption properties, ma'am? Shall we make any PNC for future use in wastewater treatment?
For
ma'am, wastewater treatment, ma'am. Polymer nanocomposite.
for wastewater treatment. Wastewater, yes, there's a possibility. But for regarding for waste plastics, that is a different thing. Very less, mostly not used for wastewater treatment because it's already a waste. If you go for pure polymer nanocomposite, there is a tremendous opportunity that you can use for wastewater treatment, because like mesoporous, you can sometimes design for porosity. According to the porosity, also you can you can separate the contaminants. There are like fiber also used, different kinds of fibers. Polymer, yes, there is a possibility of polymer, because you have said about polymer nanocomposite, not a particular nanocomposite. So there are varieties of nanocomposite options are there, and there's lots of papers dealing with the purification of or the wastewater treatment. Polymer nanocomposites are used.
Okay, thank you.
Thank you very much, ma'am. Thank you very much for sharing such an informative session. And all the offline as well as online participants are very much enriched for this elaborative talk related to the role of polymer, then about the ecological footprints, recent trends in India, plastic waste management options and prioritizing plastic waste quality, then the products, and about the nanocomposites also, and about the very recent trends of application of resins and medicinal plants also. We are very much thankful to you, ma'am. And I, on behalf of CIPET CSTS Guwahati, thank you very much for spending your valuable time with us.
Thank you, Dr. Jyotika, and all the organizers. Thank you, Dr. Hare Krishna Deka, and thank you, Director, and all the participants that who are listening to the lecture for around long 1.5 hours. Thank you all. Nice to meet you. We'll see you sometime.
Thank you.
Can I stop?
Yes, ma'am.
Okay. Thank you. Thank you.
Thank you, ma'am. Looking forward. So, dear participants, now tea break is there. We will meet again at 12. And at 12, Praveen Basab, Joint Director of CIPET CSTS Ranchi, will talk on single-use plastics. So, online participants can stay in the same line, or they can rejoin again at 12. So, please do not be get late. By 11:59 a.m., please everyone join the session. Thank you so much. Good morning, sir.
Good morning, madam. I'm ready.
Yes, sir. We are going to start by 2 minutes, sir.
Okay.
Actually, the first section has last up till 11:45, so tea break was a little bit late. That's why, sir.
Okay.
We are going to start, sir. A very warm good noon to all the participants and respected resource person Probin Basov, sir. Before the talk, I just want to introduce sir among all of you. Probin B. Basov is serving as the Joint Director and Head of CIPET CSTS-GUWAHATI. Sir is an MTech in Mechanical, and Sir had postgraduate diploma in Plastic Engineering as well as postgraduate diploma in Management. Sir has expertise in plastic processing and plastics recycling techniques. Sir had more than 17 years of experience. And apart from that, Sir had vast professional experiences. PUF Damar worked as sandwich implant trainee for 1 year at Caprihans India Limited, manufacturers of calendared plastic films at Nasik. Sir had worked as project engineer for 1 year for installation and commissioning of thermoforming PET sheet plant at MS Nail Extrumi Pack Private Limited, Palghar. Sir had exposure to different laboratories and different associations abroad also. Few of them are Sir has attended training program on DSC, TGA, TMA of 5 days duration at TA Instruments, Philadelphia, USA. Attended China Plus in the year 2015. And he had number of awards, among them internal auditor as per ISO 9001-2000. He is a qualified inspector as per ISO 17020. He is a recognized internal auditor as per ISO IEC 17025-2005. We are privileged that we got the opportunity to have Sir among us for delivering his expert lecture. Sir has 2 lectures. Today's lecture is on single-use plastic. So over to you, sir.
Thank you, Jyotika madam. And I think I will start my presentation. Can you see my slides, madam? Madam, can you hear me and can you see my slides?
Sir, we are not able to hear you, sir.
1 minute, madam.
Sir, am I audible to you, sir?
Yes, madam, you are audible.
Oh, yes, yes, sir.
Can you hear my voice now, madam?
Yes, sir.
Can you see my slides, madam?
Yes, sir.
Okay, madam. Thank you. So I will be giving a presentation on single-use plastics. What are the types? Then what are the impacts on environment because of single-use plastics? And I will be also discussing what is plastic product manufacturing. What are the opportunities which are available in plastic product manufacturing? What startups can start their business or entrepreneurs can do in plastics engineering. So that part also I will be covering at the end of my presentation. So this is my presentation for today. Tomorrow I will be discussing more about advancements in plastics engineering, what are the advancements which are going on, and how industry 4.0 is associated with plastic industry. So that I will be discussing in my tomorrow's lecture, same time. So I'm thankful to CIPET Guwahati for giving me an opportunity. So I will be starting my presentation. So already madam has read out my biodata, wherein details she has explained. When we see plastic consumption in terms of kgs in 2014-15 values, if we see, so it was 109 kgs in US, Europe it was 65, and India was way behind at 11 kgs in 2014-15. Global average was approx 28 kgs. So if you see, value of India is very less as compared to US when we compared in 2014-15. And now if you go for 2020, 21, 22, so you will find that it is approximately 20 kgs in which India is consuming plastic. So it is very less as compared to the developed countries like US or Europe or China. So we are consuming very less amount of plastic as compared to the developed countries. When we see plastic consumption, we should also understand how much per year we are consuming plastics in terms of tons. So 1996 was very less, 61,000 tons, which we are consuming plastics. Whereas in 2017, it was approximately 178 lakh tons. So definitely that value was very high in 2017. And 2021 value, if you see, it will be approximately 200 lakh tons of material which we are consuming. So this consumption is also increasing very fast. So definitely these values we can just have a look wherein the consumption has risen to a very fast value, and it has taken a lot of demand, because since demand is also increasing, consumption is also increasing in terms of packaging, in terms of other products which are like automobiles and all that. So definitely your consumption of plastics in India is definitely increasing. So these are the values which I have just put it in format. So now when we say plastics, then from where this plastic comes into life, or where does it comes, this plastic, from where it is, what is the raw material of this plastics? So raw material is basically your crude oil. So many times it is also called as black gold, they basically called. So crude oil, again, it comes from natural materials, like it will be there in terms of dead marine plankton, which will be there for 300-400 million years ago. It will be put deep under sea, which will be having plants and animal remains. It will be having sand and silt which will be put on that, and definitely pressures also will be coming, degradation will be taking place. So after millions of years, with very deep inside, this heat and pressure which will be applied, and then at the bottom this particular crude oil is formed. Okay, so this crude oil is again formed and it is drilled back. You are drilling it in terms of drilling wells. So these wells are there for drilling. They will be removing this crude oil, and then it will be transported to the ground sources wherein it will be distilled. So distillation columns will be there. So this is how it is done. So you have extraction systems. I will not go very much in detail because this is very basic things which we should already know. So it will go in extraction, wherein this material oil will be, crude oil will be extracted. It will be going for refinement phase, wherein this material crude oil will be going through a distillation column, wherein you fuel oil, diesel, kerosene, petrol, all these materials will be removed at different temperatures and conditions which are basically inside this particular distillation column. One of the byproduct is your naphtha, which is also coming from this particular refinement, wherein that naphtha is further polymerized. We get different polymers like ethylene and all that. So we get that through polymerization reactions. So this is what basically this raw material plastics we are getting from the natural resources. So crude oil is one of the basic source. So this is one of the source of plastic materials. When we say plastics, again we should know that plastics can be divided into basic two types. So we call it as thermoplastics and thermosets. Thermoplastics, when we say thermo, is nothing but heat. Plastics, basically if you go for Greek terminology or definition of plastics, it will be the material which changes shape because of heat, or it has to change the shape. So when we say it changes shape because of heat, we call it as thermoplastics. So thermo is heat. So because of heat, the shape is getting changed. So we call it as thermoplastics. When we say that thermosets, so thermo, again heat, and set means it will be taking a shape, particular shape, whatever shape may be there, so that shape is being formed. So we call it as thermosets. So basically thermoplastics and thermosets, these are two basic types of plastic materials. Thermoplastics, again consumption is very high, lot of materials, lot of applications are there for thermoplastics. If you see the values, you will understand that polyethylene, polypropylene is taking large chunk of share of your thermoplastic materials. When we say thermosets, again when you apply heat, that material will set, and if you try to again melt it down or you try to break it down, it will be very difficult to melt. It will burn directly, that material. So we call it as thermosets. So materials like urethanes, your unsaturated epoxies, melamine, formaldehyde, phenol formaldehyde, all these materials will come under thermoset resins. Okay, so basically thermoset resins like melamine formaldehyde or urea formaldehyde, this will be in powder form, raw material, whereas other materials like unsaturated polyesters, unsaturated epoxies, they will be in liquid form. Whereas in your thermoplastics, basically the materials will be in granules form. We call it as granules. Virgin material will be in granules form. You can also have materials in the form of pellets. So you have colored pellets also which are there. So it may be reprocessed or compounded material which we are referring when we say pellets. So these are forms of raw material. You can also get thermoplastics like polyvinyl chloride in powder form also. You can get in powder form also that type of material. So depending on the application, depending on the requirement, these materials are available. So thermoplastics and thermosets are these two basic criteria or categories of material in plastics. Consumption of thermosets are less as compared to thermoplastics. You can see the values also. So kilotons consumption was there, whereas if you see consumption in terms of thermoplastics, it is very high. Okay, so just comparison value, if you find that it will be consumption in thermoplastics very high as compared to consumption of thermosets. When we say production or when we say material, then production also comes into picture. So we'll find out that lot of material in plastics is going for packaging applications. So packaging is one of the major applications. We have building and construction, we have textile sectors, we have consumer products, transportations. Also, these are the sectors wherein plastic materials will be used. So production wherein the values, if you see, it is million tons of values which was used in packaging. So packaging is one of the major source of your production where plastics is very commonly used. So packaging application is one of the developed area, and again lot of plastics will be used in packaging application. So these are the values where your plastic is being produced and is used for different applications. So this is the slide. And now when we say consumption of plastics in packaging is more, definitely waste generation values, if you find out, you will understand that waste generation in packaging also is very high. So when consumption is definitely very high, waste generation also will be very high. So packaging applications has lot of waste which is generated in packaging. So packaging of different articles, food products and all that. So packaging has a lot of waste which is generated. You have other sectors, like it may be other sectors which are not included in this particular list, like waste is generated in consumer, it is generated in transportation, electrical and electronic goods like mobile phones or computer gadgets and all that. So waste is generated in different sectors. This value for 2015, we have seen that 141 million tons of packaging waste was generated, whereas now this value in 2021 will be very high. So packaging is one of the major source of generation of your waste in plastics. Okay, so this is the values which I wanted to show you. Now when we see waste generation per country also, so different countries, definitely developed countries, countries like China and all that, so they have very large waste generation. So these are values in 2010. whereas it was dark green color is given in terms of more than 50 million tons of waste which is generated. So these are values for 2010. So definitely again 2021 or 20, these values will be very high. Okay, so this is waste generation per country. India, we can find out nearly 5 to 10 million tons of waste which is generated in our country. So these are values for waste generation. Then, and these are some of the common pictures you can see in newspapers, news articles and all that, wherein a lot of waste is there in water bodies. So this you can see so many times. These are some of the pictures which are again negative pictures for plastics and plastic professional. So where does this plastic comes in ocean? When you see so many pictures and how it is being generated, how it is going in ocean. So we'll understand that source of your marine litter, it will be basically industrial source, like some industries which are generated a small quantity or small size of plastic is going inside an water body, or it is going through a drain and then it is going inside a bigger water body. Okay, it may be because of pollution in our local municipal corporation systems, wherein like we have buildings, we have so many colonies wherein waste which is generated goes through the flush and then goes through the drainage system inside the water bodies. So many types of waste which is there, it is going inside your marine body, water bodies. These water bodies, like it may be a small river and all that, so it goes inside, finally inside the sea or inside the seashore. So definitely when it goes inside a sea, definitely marine bodies or marine fish or other living organisms in your sea will be affected. So this is again one of the major source of problem which is being faced by so many countries. They will be calling it as microplastics. Okay, so one common term which they are using is microplastics, wherein these plastics in very small size goes inside these water bodies and it will be going inside our fish or other marine bodies, and then it will be creating pollution or it may be creating the life hazard also. Okay, so this is how it is going inside your marine bodies. But we should also remember that this particular plastics, which is single use plastics, like we use syringes, we use single use syringes. So that type of syringes have also helped us in protection against coronavirus. So they have been protective for us. They have given us vaccines. So we are using vaccines, and then it is a single use syringe only which we are using in medical applications. So definitely it has also saved us in a bigger way. So this is also one point we should also not forget. So this is again single use product only, that syringes, that is injection molded. Main problem comes in this picture. When you see this picture, you will understand key plastics, there are different products which are there, and it is having some metal, it is having some food wrapping, it is having some organic matter also which is going inside the dustbin. So this type of dustbin which is there, it is very difficult to have recycling. Okay, so this is one of the major problem. Because of this problem only, so many problems, other problems will be coming, like recycling will be a problem, how to recycle properly, how to segregate, how to separate. So all this problem will come when we see this picture, wherein we can see that some organic matter is getting mixed with plastics. There are some papers also, there are some metal bodies which are also there, and then again that food article which is should not be there inside that plastic, it is not cleaned thoroughly. So that is also one of the major issue in recycling. Okay, so these are some problems which we should see, and we should avoid that in recycling. So when we say different plastics, definitely there should be some identification code. So there are different identification code or recycling code which we basically call. So many times there is a confusion ki sir, this behind the bottle there is written 2 number is written, that means that bottle is recycled only 2 times or what. So like that many times question is there, but we should understand that recycling symbol, it is there for identification of plastic materials. So 1 number is given for PET material. So PET material, like your drinking bottles made up of PET material, Bisleris and Coca-Cola and all that. So all these bottle will be made from PET material. So 1 is the number. 2 for HDP they have given. 3 for PVC. PVC in terms of your pipes, leather jackets, your so many items which are made in PVC. So these are all made application. So serial number 3 they have given for recycling code 3 for PVC. LDP we have polypropylene in terms of 5 number. 6 number is PS. And other materials which are not covered under 1 to 6, they will be all covered under 7. Okay, so 7 is the code which is given for others, because we cannot remember all the numbers. Like if it would have been up to 12, 13, 14, who would have remember all these numbers? So up to 6 most of the commonly used products which are made, they are made mainly through 1 to 6 number only, and that material only will be going more in recycling, more in waste system. So we should identify that material easy. It should be easy for rack pickers, it should easy for the recyclers. So therefore this identification number up to 1 to 6 they have given. And other materials like nylon, maybe their polycarbonate, maybe their, so all these plastic other materials, they are coming under 7. Okay, so this is what the recycling identification code it is given, and this code is printed either at the bottom of the product, it may be printed at the bottom or on the sides, so that when you are that particular rack picker or the recycler, he is seeing the product, he can see the number which is written at the bottom or on the side, and then he can go for recycling. Okay, so this is important, plastic identification codes. Then when we say single-use plastics, as the name indicates, single-use plastics. So single is the term, means it should be used at least once. So it is used for only one time. So that is single-use plastics, they are basically called. And according to different organizations, there are different definitions which are available, because this is one of the major issue creating area, single-use plastics. So single-use plastic as per CPCB, these are the products basically they are used for one time and then you throw it out and you can go for recycling or you can throw it out, so that we call it as basically single-use plastics. United Nations says that single-use plastics are plastics which are made up of products which are made up of HDP, LDP, PET or polystyrene. So these materials, if they are there, some product is made from this material, we call it as single-use plastic. So United Nations, they have this definition for single-use plastics. European Commission, so European Commission also has a lot of work, they are doing a lot of work in terms of recycling and waste management and all that. So European Commission says that single-use plastics can be used only one time. So they are used one time and then they are disposed of. So they call it as basically single-use plastics. So basically from all this definition, we can understand that basically these single-use plastics will be used only for single time or one time. And then we either throw it out or we recycle that material. Okay, so these are single-use plastics, or SUPs very commonly it is called. So very commonly used SUPs are these particular thin bags, carry bags, which we can see everywhere. So thin carry bags, which are having very less thickness. Then your wrapping films, you have cutleries, foam powder products which are made either cups or bowls or plates. Mainly for food items they have been used. You have cigarette butts, you have plastic bottles which are PET, made up of PET and less than 200 ml, 250 ml. So that type of bottles which are smaller size bottles. You have straws, you have cutlery items and all that. So all these products which are made from this type of applications, so these are all called as single-use plastics. Okay, so these are some of the products which I have shown along with the photographs for easily understanding. So you can see that so many products are there, like it may be made up of foam or it may be made up of small plastic materials, that may be expanded polystyrene foam also, which can be used for making cups and plates. So these are all coming under single-use plastics. Okay, so these are the single-use plastic items. If you go for CPCB, now Central Pollution Control Board is one of the body which is monitoring all these activities. They are checking all the single-use plastics which is being used in the country. They are giving a lot of legal frameworks. Also, they have given a lot of legal frameworks in terms of plastic waste management rules. So plastic waste management rules in 2016, it was there. Then thickness was also mentioned, this much thickness is allowed, lower than this thickness is not allowed. Then these rules were again amended in 2021, they were amended again, and they have told basically this single-use plastics is basically it should be disposed of or it should be recycled. They have slightly changed the definition. Again, they have given some rules in terms of prohibition of manufacturing, in terms of import, in terms of stocking, distribution, sale. So all these rules also they have implemented in this amendment rules which they have given in 2021. They have given slightly the products which are coming under single-use plastics, like balloons, earbuds, then ice cream cutleries, plates, cups, all these items they have included in these single-use items. And they have also included PVC banners. So banners which are less than 100 microns, so 100 micron thickness, if it is less than 100 microns, so that also is included in single-use plastics. They have also included polystyrene for decoration, foaming, foam material, foam sheets and all that. These are also included in single-use plastics. Okay, so these have been changed slightly in 2021 August only. They have slightly amended this definition for single-use plastic, CPCB. And again, they have also mentioned the thickness of carry bags, because this is mainly one of the major issue, that is carry bag, which we see in environment. So up to September 2021, 75 microns was allowed. After 2021 September up to December 2022, 120 micron is only allowed. Okay, so any thickness which you are taking, should be now greater than 120 microns after December. So after December, it should be minimum 121 micron should be there, because 120 or less than 120 will be banned completely. Okay, so this is again new guidelines or rules they have mentioned here. So this also we should follow. Then this particular change in thickness is nowhere related to your machine, because your machine can produce very lower thickness also, it can produce higher thickness also. So we don't have to change anything on the machinery itself. On the machinery platform, we don't have to change anything. Your alternation of thickness is possible in your machine itself. So if you are producing 60 micron film, you should go ahead now with 75 and above microns. So it is possible with the machine now. So many times people are telling, no sir, this because of this thickness, how we can change our machines? We need to change something in machine. We have to change die. We have to change this. We have to change that. It will be putting us extra cost and all that. So nothing extra is there. You can change these thicknesses in your machine, what machine you are using now. So this also is been mentioned in the plastic waste management rules. So there is no alteration in machinery which is required. Again, this particular rules of microns and thickness is not applicable to compostable. So compostable plastics, biodegradable plastics, these are not coming under this particular micron thickness. So compostable plastics are allowed. Again, these compostable plastics has to be certified by a CPCB. So CPCB should give you certificate कि okay, your material which you have submitted has been compostable, and then it can be go ahead with the manufacturing of carry bags. So that also is important. Plastic packaging will not be used in tobacco products. So tobacco and related products, they will be not using any of the plastic packaging in their packaging of items. So this also has been mentioned in the CPCB rules. And again, you should also remember SUPs are not included, wherein if you are using a multi-layer packaging which is more than 50 microns, so your packaging which is there more than 50 microns, it is allowed. So it should not be less than 50 microns if it is a combined sheet or a film packaging which is having multi-layers and all that. So that also they have added up in rule 4D. So this also has been included in this legal framework of plastic waste management rule. So I have gone slightly in detail because many times there is a confusion in mind, ki, sir, this is allowed or this is not allowed. If I go for manufacturing of this particular product, will I get my license and all that? So this also should be properly remembered. Okay. So I will be sharing this presentation with madam and she will be sharing with you. So I can share this presentation, no problem. So recycling of plastics is again a major problem now. So we came to know about single-use plastics. Now how this recycling takes place, or what are the problems which we are facing in recycling. So this also should be understood properly, because a recycling machine can cost you 20 lakhs, 30 lakhs and above. But if you want to put so many machines in a particular area, you will be finding it very difficult to get good quality of raw material. So good quality of recycled waste also is not available to many of the processors. So many of the processors have this particular problem. Ki, sir, I am not getting good quality of plastic waste for my machine, and my machine is having capacity of 250 kgs per hour, but I can get only 50 kgs per hour or 100 kgs per hour because I am not getting good quality waste. So this is also one of the major problem which is faced by most of the recyclers. So how and why they are facing this problem? So we should understand that point also. So we know that plastics, basically 10 to 12 main polymers are there. Like if you ask me names also, I can tell you, okay, sir, PP, HDP, LDP, nylon, polycarbonate, and PET, and all that. I can tell you easily 10 to 15 grades, and then that 10 to 15 grades are again divided into different capacities or different categories. Like it may be PP material if you take. So you have injection mode grade PP, you have blow grade PP, you have film grade PP. Then again, if you go for polyethylene, you have polyethylene, LDP, HDP. Again, LDP, you have film grade, you have injection grade. So all these are again divided into so many types and grades. Okay, so this also is one of the major issue which is coming to issue, because you cannot mix injection grade with blow grade. You cannot mix with particular two different grade, because we know that MFI is one of the major issue, because lower MFI materials will be more preferred in extrusion, whereas higher MFIs like 50, 55, 60 and all that will be preferred in injection molding. So you cannot mix these two materials also. This will be a problem in recycling. Secondly, many times we are not using virgin polymer materials. Like we are not using most commonly virgin PP or virgin LDP and all that, because we are using some mixing with them. We are mixing some master batch, we are mixing some colorants, we are mixing some pigments, we have additives which we are adding. Like additives maybe in terms of fillers, it may be in terms of your antioxidants, or it may be in terms of flame retardants also, if that type of application is there. So many additives are added. So material with one additive cannot be mixed with material with other additives. Maybe that parent material PP is same, but PP with flame retardant and PP with normal pigments cannot be mixed together again. So this will again create a problem. So this is all problems which are being faced in recycling. Again, we have used multi-layer films. Multi-layer films have different layers inside it, so that layers also has to be separated and then it has to be recycled. So this also creates problems in recycling. So all these problems are being faced during recycling, so this also should be properly remembered. So these are just a challenge which is there in recycling. So these are challenges which I have just put forward for your understanding. Now when we say elements or recycling, or what are the essential elements which are there in recycling of waste, we should understand that one of the major source or major important point in recycling is a stable supply source, which I was discussing at the start. Many times machines are available, technology is available, but plastic waste of that quality is not available. Okay, so we should have a stable supply source. So stable supply source is very important. So we should have a stable supply source means we should have a proper collection system. We should have a sorting system, we should have cleaning and drying system, and then it has to be recycled inside your machine. So that has to be happening, it has to be taking place. Because if your stable source is not there, suppose you have one type of raw material supplier where he's giving you 100 kgs today, that particular waste of LDP suppose, and tomorrow if you ask him, okay, you give me material, he will say, no sir, today only 10 kgs available, only 12 kgs available. So that also will be creating problem, because you have investment so much in machinery, you have invested so much in manpower, power, everything you have invested, and if your machine is idle, then it will not be okay. So therefore you should have a stable supply source. So this is very important in recycling. Secondly, whatever process you are using, so it may be a mechanical recycling, it may be chemical recycling, or any other process you are using, it should be economical. So it should be economical in terms of finance, it should be economical in terms of other availability of raw materials, availability of machine parts and all that. So it should be economical, it should be proven and environmentally sound. Okay, so proven, it is important, because many countries like China or Japan or Korea, they have a system wherein they are using pyrolysis technique. Okay, they are using pyrolysis technique for recycling of plastic waste. So that plastic waste, suppose 1 ton of waste is put inside this pyrolysis plant, and that waste is converted into oil. So oil which you get is approximately 600 to 700 liters. So 1 ton is, or 1000 kg is giving only 600 to 700 liters of oil, but other remaining material, like it may be 400 liters or 400 kgs of material which is left out. So again, it is dangerous material. Where to dispose of this material? You cannot put inside a water body, you cannot put it inside the ground. So this also will be creating problem. So your process which you are using recycling, it should be environmentally sound also. It should not create problems inside. Okay, so it should not create problem in your environment. So that also you have to check. Thirdly, you have to see that end use applications. So whatever process you are following, it should have proper end use applications. You should have proper market outside, because if I am producing waste material in terms of 100 kgs per hour or 200 kgs per hour, I will understand later on that no, I have no market for my material, and I am producing of this particular tons and tons of material, but there is no market available. So this will also create problem. And if this material is lying at your own end, then how you will go ahead with your production? Okay, so this is also important. So you should have market available for your materials. So for market availability, definitely you have to see what type of material you are processing. You should know the properties, you should know what is the MFI, what color you are getting. And then if you want to increase the properties, like terms of tensile strength or elongation and all that, so you can add some virgin materials also inside this your recycled material. You can make 10-15 different combinations, and then that combinations can be marketed. colors can be marketed in the market, and definitely you will get good orders for that also. So definitely that also requires your technical inputs. So technical inputs is very important. So you should develop that type of inputs, and you should develop that end use applications for your plastic recycled material. Okay, so this is again important. And consumer confidence is also important, because now Ukraine, you have fighting which is going on, Ukraine, Russia, polymer rates have increased to 10 to 15 rupees per kg. If you see the market rate, 150, 140, it is going on now. So raw material rates have also increased. Definitely more and more market will be there for recycled material. So recycled material will have good value, and definitely so many applications are again being developed for recycled material. Okay, so these are some of the essential elements which are important in recycling. Now, when we were discussing essential elements, definitely we were also discussing regarding different technologies which are available for plastic waste management. So we have conventional technologies which are available. We have new technologies or advanced technologies which are available. Conventional technologies, we have normal recycling, which we call it as mechanical recycling. If mechanical recycling is not possible, we go mainly for landfilling. Directly material goes in landfilling sites. If it is single-use plastics or plastics which is used in medical applications, you go for incineration. Okay, incineration is nothing but burning in presence of oxygen. So you are directly burning that plastic waste in presence of oxygen, and whatever the heat is generated, you are taking that heat, you are putting inside a boiler system wherein steam is generated. You can generate power from steam, or that steam can be used for any other applications like washing and all that. Also it can be used. So this is incineration, basically it is called. New technologies, you have plasma pyrolysis, which I was telling basically. So pyrolysis, we convert plastic waste into oil. So you can also convert it into syngas or gas, which is one of the byproduct in pyrolysis. Pyrolysis, when we say pyrolysis converts your plastic waste into fuel, basically oil, in absence of oxygen. Okay, so this is very important. Pyrolysis is done in absence of oxygen. Again, pyrolysis can be divided into two types. It may be you are adding some additive in specialized material which will faster the reaction. Without additive, you have a process in pyrolysis wherein it will take very higher temperatures. Okay, temperatures are very high, wherein that material will burn and that will be converted into carbon molecules. Okay, so these are all technologies which are available. There are also new technologies which are coming ahead, like your bitumen roads. So polymer or plastic is mixed with this particular fuel, coal tar, and then it is put inside the road making. So road also, it is very important, because now a lot of roads are being generated. So per day they are telling 3-kilometer road is being generated anywhere. So there also it is now having good use. So plastic waste can be used in bitumen roads or polymer blended roads. So liquid fuel, already we have discussed pyrolysis. Basically in liquid fuel we can convert. Plastic waste is also used in cement kilns. So it is used along with the fuel, like it may be used along with the coal. So coal plus plastic waste is added inside this cement kiln, and heat is generated, which is used for making cement. Okay, so cement plants like L&T, they are using, then AICTE Birla Group also, they have a cement plant wherein they have started using small quantity of plastic waste also. Okay, so plastic waste is also used along with the other fuel, so inside the cement kiln. So these are two technologies which are available. When we say recycling, again, recycling, when we say we have to convert ourselves, or we have to change ourselves from a linear economy to circular economy. So what does linear economy means? So when we use linear economy, that means we take material, you convert it into product, and then if application is over, then you dispose of. Okay, after disposing, there is nothing happening, it is going to landfill, or there is different body or different person who is taking this material and doing something recycling on it. Whereas when you go for circular economy, we use the product, whatever product we have manufactured from plastic, then we again recycle the product. Okay, we recycle it into some particular raw material. Suppose waste raw material we are producing, and that plastic waste raw material, which is either PP, HDP, any material which is used, so that is converted into again some products. Okay, it may not be same product which is used, so it may be a different product. So we are going for a circular economy. So this circular economy term is again coming inside this plastic waste management rules. So there also it is properly mentioned that it should be a circular economy, we should go for recycling of plastic materials. Okay, so this is what the difference between linear economy and circular economy. And when we say circular economy, we should also understand that repair, reuse and recycling is very important. So if it is possible to repair the product, we can repair it. Suppose some small crack is there, we can see that crack is getting healed. If crack is not there, we can reuse in some other applications. Like suppose it was a bucket and it was not being used for water, carrying water, you can use that bucket for planting trees and all that. So that type of application reuse also can be done. Okay, so this is basic. So currently we are doing very less amount of circular economy, or we are converting very less amount of material into some other useful products, and most of the material goes inside landfill and waste. But we should understand that most of the material should now be reused or recycled, so that less amount of material goes inside the landfill. Okay, so this should be the future, and then only we could have this particular price rise which can be controlled, because virgin material price has been risen to so big value, so it is very difficult to get profits. It's very difficult to get orders on that particular cost which was in olden days. Okay, so it has increased to a very large value. Next, when we say plastic waste management rule, it is also having one term which is called as extended producer responsibility. Okay, so extended producer responsibility, or EPR it is basically called. So EPR is nothing but whoever is the producer. Suppose there is a producer like Hindustan Unilever, and he is the producer for particular shampoo brand or a particular plastic material he's using for packaging. So it is his responsibility that whatever the plastic waste he's using in his product, it has to be coming back to him, or he has to pay some particular material amount he has to pay, so that it can be recycled again. So it is his responsibility that whoever is the producer, he has to give responsibility for the waste which is being generated. So if you see a lot of bottles like Bisleri or Coca-Cola, on that bottle it is written, if you give this bottle back, or if you give 1 kg of this bottle back, we will be giving you 20 rupees, 40 rupees, like that. Or if you give 1 bottle back, we will be giving you 1.5 rupees or 1 rupee, like that. So this is coming under EPR. Okay, so that is called as extended producer responsibility. So the producer which is producing the plastic product, or he is the manufacturer, it is his responsibility. His responsibility is extended, that whatever waste will be generated once the product is being used, so it is the responsibility of the producer to see that that waste also is recycled and it goes in proper application area. Okay, so that is coming under extended producer responsibility. So our plastic waste management rule also has a lot of terminology and lot of coverage on this EPR also, and the EPR is being followed in India properly. Okay, so this is EPR basics. So basically when we see this picture, we should understand this plastic waste which is generated is one of the major issue, but segregation, but separation and collection of this waste is also one of the issue which is being faced in country like India. We can see these people who are doing this type of work are basically informal sector. Okay, this is not a formal sector which is being taking place. So it is informal sectors. There may be these poor people who are working in this sector. There may be small children who are not going to school or who want to have an extra income and all that. So they may be working and they may be collecting this plastic waste. Basically, we call them as rack pickers. So these rack pickers and all this sector which is coming, it is basically informal sector. So this sector, if it is converted into formal sector, wherein they will be given proper uniform, proper clothes, gloves and all that, personal protective equipments and all that. So if this is happening, then this problem will not be there. Okay, so these people, they will be going in land filling site, they will be working full day, they will be removing plastic waste from the waste which is being thrown. They may separate or they may not separate also the waste, and then they will be giving to a wholesaler. That wholesaler will be collecting that waste and then he will be giving to the manufacturer and all that, recycler and all that. Okay, so this is basically informal sector which is there, and a lot of activities are taking place. A lot of NGOs are also working in this sector for making their lifestyle good. So this is also one of the major issue, that this sector is informal. Basically, we have not put more attention on this sector, and if you put more attention on this sector, definitely this problem of waste also may be solved very soon. Okay, so this is one photo just I wanted to share. Now, when we see this particular single-use plastics, there are some priority areas which is been mentioned by UN Environment Committee. So they have given some basic priority areas, like how we can go ahead with this single-use plastics. So first area which they wanted to cover is you are improving that particular waste management system. So they have told that we should improve first waste management system. Improving waste management system in terms of segregation of waste. So how to segregate waste, how to separate that waste, like how to separate plastic from organic, metals, paper, etc. Then effective collection system, effective segregation system, effective transportation system is also very important. So this collection, segregation, separation should be near to dumping sites. It is very well, so that our lot of transportation cost is also removed. So this all has to be given in terms of systems should be developed, and whatever the material you are removing, like it may be plastics and all that which is removed, so whatever inputs we are putting for converting that plastic waste into product, so that cost also should be effective. Okay, so it should be effective. It should not happen that I am doing all this material cleaning, drying, and then I am converting into granules, and I will understand that, oh, that cost is more than virgin material. So that is also not required, because it should come less than virgin material. So that cost effectiveness also has to be checked properly. And once this is there, definitely our dumping sites will be reduced, and dumping sites should, most theoretically or practically, we can say that dumping sites should not have this type of material in them. Before going to dumping site itself, we have to remove the material. So if this system is developed, definitely this problem of single-use plastics will be removed. Secondly, we should promote some alternatives, that is eco-friendly alternatives we have to promote to single-use plastics. Like it may be in terms of single-use plastic recycling should be done. It should not be used in application areas where a lot of material is generated. We should have some support from government also in terms of technology development. They should have some public-private partnerships and all that. So if these all things have been developed, then definitely we will be getting some alternatives also to single-use plastics. Then we should educate consumers. Like these consumers are one of the major area where they should not use these single-use plastics. So education in terms of awareness, in terms of schools awareness, then syllabus, we can include these single-use plastics. Campaigns can be done, awareness campaigns, these newspaper advertisements and all that. So this type of activities can be done to educate the consumer, so that they will not use this particular single-use plastics. Then we have to enable voluntary reduction strategies also. We should have some reusable bags which should be promoted, so that they will be not using these plastic carry bags. Then government also should have some regulatory materials or instruments or levies which should be possible. If you use this type of material, then we will be banning your organization, or we will be closing down your organizations and all that. So these are all things, if we do this ban or other strategies also, if we do at the last stage, definitely these single-use plastics will be removed from the environment. Okay, so these are all the priority action areas which is important here. It may happen, then they may levy a particular tax also in that case. Suppose it is getting increase in large content, definitely government may think of imposing a tax also on the single-use plastics, and then they may ban that activities, production areas and all that. So they may completely shut down that activities also. So this will be the last stage wherein single-use plastics have to be removed. Okay, so these are some priority areas. So these are some of the alternatives. Just I am showing you photographs. These are simple alternatives which are being followed. Many of them may be followed also in our day-to-day life, like reusable bags, reusable safety razors. Then nowadays bamboo toothbrush are also coming, and then this type of refill type of containers are again getting good market demand. So you take your own glass container or a steel container, and then you fill it as per your requirement, 1 liter or half liter and all that, and then you weigh and you pay the money. So this also can be one of the activities. So reusable containers can be taken, so you don't have to depend on new packaging every time you are using this type of material. Okay, so these are some of the alternatives. Then some of the activities which are done all over world, like they may be using toothbrush or cutlery items which are made up of bamboo or wood and all that. Some of the biodegradable packaging also is one of the application. So this type of alternatives are already available in market. So these particular plastic bottles are put into small pieces, and then they are making brooms from this particular bottle. So this is also one of the application area. They are using that particular plastic bottles. Most of the organizations, like some NGO like EcoBrick, they are putting waste material inside these bottles, and they are using that bottles for making walls. They are making walls in houses, or wherein there is a seashore. So seashore, they will be protecting the body against the waves. So there also they may be using this type of bottles with plastic waste. So these are some of the examples, simple examples. Nowadays straws, which was one of the major source of single-use plastics, plastic straws. So that also been replaced by eco-friendly straws. Then there are containers which are there. You can also find some biodegradable type of material which are used in straw. Then you have spoons which can be eaten up after you are finishing the particular food item. You can also eat the spoon itself. Okay, so that also can be made using bakery materials. So bakery products can be made using that type of applications. So these are some of the alternatives which I have generally shown. Many of the NGOs like Eco Curry, they are converting this plastic waste along with fibers like your cotton fibers. They are mixing with your plastic waste with cotton, and they are creating so many application areas, like it may be purse or it may be small items which are just shown in the figure. So this also can be one of the alternatives which are available, the waste which is available in environment. So this machinery are again being converted or again been slightly developed or changed based on the requirement, because you have to add your plastic waste along with the cotton or cotton fibers. So therefore again small changes in machineries are also possible. So this has also been done, and then it is being converted into products. So in home decoration also, you can see these, basically these are the caps which are your bottle caps. So these bottle caps are being used for some home decoration application also. So this just I have shown you in this case. So these are some coasters and some dresses for Barbie dolls and all that. They are also been made from plastic waste materials. So these are applications area. A lot of application areas are developed. A lot of new application areas are being developed again. So they have been very good demand in market also. So these are some of the paver blocks which are been made from plastic waste. So smart city projects, they have a lot of paver blocks which are fitted on the roadsides. So roadside paver blocks are manufactured in injection molding using this particular plastic waste, and then they are interlinked or interfitted inside each other. They have interlocking material. So interlocking can help them in easy fixation and then saving of material also. Okay, so these are some of the alternatives which are available. You can also make fibers from PET waste, and that fibers can be used for making fabrics. Fabrics can be used for making t-shirts and bermudas and all that. So these are also applications of PET material which can be used to convert from your PET bottles to fibers. Okay, so this is one of the major applications. A lot of our household items have this particular PET fibers. So these are going ahead with manufacturing products. What are the products and what are the manufacturing areas which are available for using these maybe single-use plastics or other plastic materials which are there. So many of the startups or entrepreneurs can think of these particular areas. So first of the area which I would like to discuss is acrylic button manufacturing or plastic button manufacturing. So this is one of the major area. We have seen so many t-shirts or shirts. We have 6 shirts or 7 shirts. We have buttons which are fitted on that. So these buttons can be manufactured by basically 2 processes. We have one process that is injection molding. So we have injection molding machine. We have injection molding mold. So we can manufacture this button. Second process, we call it as die punching system. So wherein a sheet is taken as a raw material. You can find it in my left hand side figure. So there is a raw material sheet. It can be acrylic sheet or it can be any other plastic sheet which you want to convert or you want to make the buttons. So that sheet is being fitted inside a press type of tool, and then you are putting a tool cutting that particular circular holes or circular buttons inside this sheet. Then you need to have 4 holes also for putting threads. So that also can be done. So there are 4 holes which are there. So you can put it through a drill system. So you can make that 4 holes. So this is one of the simple technique which is used for manufacturing of buttons. Cost wise, if you ask me, this type of machine may cost you 50 to 60,000 only, wherein a punching die and that setup has to be developed. Raw material you have to procure in form of sheet. Okay, so you have to procure the sheet form of raw material. So this is one type of button manufacturing process. Second process, which is again very commonly used, which you can have designer buttons, 2-layer buttons and multi-layer color buttons and all that. So that is injection molding. So injection molding of buttons, you have mold which needs to be manufactured. So in the second figure on top, you can see these are the molds. So these are detachable molds wherein you can remove one particular design and you can detach and put second particular design in the same mold. So different design molds are available here. So you can use this mold in your injection molding machine. You you can produce. And then you can have multi-cavity molds also. You can see the red color photograph wherein you have near about 16 cavities on one side, 16, 32 cavities. So you have to have so much products which can be made in a single shot or single cycle. So this is injection molding process. You have very good control on product, control on quality, raw material which is going inside. Then secondly, after forming in injection molding, you can go ahead for cutting. So this button can be separated from the feed system, and if you want to have plating to be done, silver plating or golden plating on the buttons and all that, so that also can be done in a secondary process. Okay, so this is button manufacturing in injection molding. So button manufacturing in injection molding is very commonly used in industry, and you have higher production values which are available, so you get good production rate, and different design, different raw material combinations can also be done. Okay, so this is injection molding process for buttons. So this will be a machine. If anybody is not knowing about injection molding, they can understand. So this is a basic injection molding machine. Basically it is classified on terms of tonnage. So what is the tonnage of machine, what is the short capacity, how much you can melt the material and send inside the mold, so what is the maximum short capacity and all that. In terms of grams, you can give that short capacity. So this is injection molding machine. So whatever mold you have, either it may be a button mold, it may be mold which I have shown at the bottom, like it may be a bucket mold, it may be a container mold, lid mold. So that mold can be fitted on the machine. You can inject your material, raw material, like PP, HDP, LDP, any material, thermoplastics, you can put it inside the hopper, and then it will be injected inside the mold after melting. Okay, so this is the injection molding process. So this is one of the process which is very commonly used for manufacturing of so many products, like it may be buttons, it may be buckets, and all that I have already explained you. So this is very commonly used process for this particular plastic products. Second area or second film or second category of material which we would like to discuss is your bubble film. So if anybody is interested, any startup or entrepreneur, they can also think about this packaging application, bubble film. So you have again this extrusion process wherein you have a raw material which is been melted through a die, and then it is been made to flow through a vacuum type of roller, wherein it will absorb air and then give shape inside the film. So you have one layer and first layer and second layer which is coming up. So you have one layer which is getting formed in terms of bubble. Second layer is a plain layer wherein it is closing the air inside. Okay, so there is a air which is trapped inside, and then you get that bubble design on the film. So this is bubble film manufacturing. You can have machinery in terms of width. Like if I am having a machine of 1 meter width, so I can manufacture maximum 1 meter width of film. Then I can cut it as per my requirement. Like if I would like to have bags to be made, small bags to be made, I can cut it in small bags. I can seal it on one side or two sides, and then I can make a carry bag from using this bubble film packaging also. So this is also one of the major area. Again, bubble film, like your buttons, they will not be having any ISI marking or ISI standard, and all that is not available. So you can have this bubble film, you can make small bags, and you can supply to manufacturers, like it may be packaging items, electronics items, and etc. So this is also one of the good area wherein you can manufacture bubble films and supply to the market. Okay, so machine cost, if you ask me, this machine cost for bubble film manufacturing machine, which will be extruder basically, so it may be costing you approximately 15 to 20 lakhs. Okay, so that 1 meter width will be costing you 15 to 20 lakhs. Smaller sizes will definitely be available as per the requirement. So you need to contact the machine manufacturers for smaller or bigger size as per your requirement. Third product which would like to discuss is blow molding. So you have plastic blow molded containers which are there, like it may be HDP or PP containers. So HDP or PP containers can be used for manufacturing of biofertilizers. They may be used for manufacturing on packaging of chemicals, maybe there, like household cleaning chemicals and all that. So all these materials which packaging application requires this particular blow molded bottles. So bottles are basically made from HDP material or PP material, polypropylene or HDP material. It has been commonly made, and then you have caps which are been made by injection molding. Okay, so these bottles are made in extrusion blow molding process. So this is the process which is being used here. So extrusion blow molded machine is available. Again, that machine is being categorized or defined in terms of liters. Like suppose I have a machine of 1 liter capacity, that means I can produce a product of maximum 1 liter capacity and less. It may be half liter, it may be 250 ml and all that. So this is basically extrusion blow molding, which is called. So extrusion blow molding will have an hopper. It will be having an extruder wherein this material will be melted, and then it will be sent through a die. Okay. So die can be changed again as per your requirement. You can have a bottle die, you can have a small ball type of die also, or a cricket bat type of die also, as per your requirement. So you can change the die and you can make the product. Okay, so this is called as extrusion blow molding. So very commonly used machine. Again, if you ask me costing, 1 liter machine may cost you 10 to 12 lakhs. Simple machine may cost you 10 to 12 lakhs. Again, output is given in terms of bottles per hour. How many bottles you can manufacture per hour is also one of the criteria. Like somebody may say, okay, my machine, I can manufacture 1000 bottles per hour or 500 bottles per hour. So this is also one of the criteria for selection of your machine. Okay, so this is blow molding, extrusion blow molding process. Secondly, one type of blow molding process which is used for manufacturing of bottles, we call it as PET blow molding. So it is basically called as stretch blow molding process. So you need to have a preform. Okay, so preform has to be used. So you can see the right hand side corner photograph wherein these are preforms which are manufactured in injection molding machine. So the machine which we have seen at the start. So injection molded preforms are being manufactured. That preform has to be used inside a stretching and blowing machine. So at the bottom middle figure, you can find out this is a stretching and blowing machine wherein this preform are fed inside the machine. They will be heated and then fed inside the machine. That preform will be heated, they will be stretched, and they will be blown. Okay, so high pressure air is being sent inside this preform, inside your mold, and as per your design, whatever design bottle you have, so that mold are being fitted inside your machine. So you stretch it, you blow it with high pressure, and then that shape will be formed. So cooling, everything will take place inside mold itself, and then that bottles will be thrown out or it may be removed. Okay, so these are called as stretch blow molding process. So this is basically used for PET material. So PET material is very commonly used in stretch blow molding because it has very good stretch ratio. So stretch ratio is highest for any of the plastic material. The PET is having highest stretch ratio. So this will be helpful in getting very less thickness, and your weight of the bottle also will be less. So these all characteristics or advantages will help PET in packaging applications. So water packaging or juice packaging and all that. So it is very commonly preferred material for packaging applications. Okay. You may also have a small PET machine, single stage PET machine, which will be used for making your cup syrup and other syrup type of small bottles, 50 ml, 100 ml bottles. So this is also one type of machine which is available. It is single stage machine wherein everything, like you have to feed only raw material which is heated. You have to feed the raw material inside your machine itself. Preform will be formed, heating, blowing, everything will be taking place. Only output in terms of bottles will be formed. So that is called as single stage PET blow molding machine. So single stage PET blow molding will be costly machine. It may cost you minimum 30 to 40 lakhs, whereas normal stretch blow molding machine wherein you take preform from outside and then you feed that preform inside the machine, that may cost you approximately 10 to 12 lakhs. Okay, so that is the difference between the two. So single stage is definitely a costly machine because you need to have drying, pre-drying, everything has to be there inside. So this will be a big machine and output also will be very high in single stage machines, whereas this particular stretch blow molding machines which you are feeding manually, output will be slightly less in terms of like thousands of bottles per hour and all that, whereas in single stage machine it will be very high. I mean, output may be in 10,000, 20,000 numbers also. Okay, so this is the difference between the two. For information, I have just informed you. Then next, packaging can be plastics can be used in packaging applications also. Now packaging applications, we should always remember this single use plastics has to be banned. So single use plastic cannot be used. So in that case, you can use injection molding for or thermoforming for food packaging applications, like you must have seen Zomato or Swiggy. So they give a plastic container which is injection molded or thermoforming which is being done. So that type of application areas are also being developed. Then plastics can be also used for packaging of cakes. So if you see a lot of bakery items and all that, they are used in packaging. So their plastic film will be thermoformed and it can be used. So thermoforming is one of the application area. So you can see the thermoforming application. So thermoforming, you have a sheet roll which is fed inside a machine. So it will be heated, then it will be after heating, it will be either vacuum or pressure will be applied, and then that shape will be formed. Okay, so there are different combinations of molds, like it may be match die forming or pressure forming or vacuum forming and all that. So then that product will be formed, and that remaining part will be winded up in the machine, and the product which are formed will be thrown outside, or it may be collected at a separate end. So this is called as thermoforming machine. Okay, so these machines are again commonly used for so many applications. Again, here also I will be informing you that single use plastics, you should be very careful, because this particular cutlery plates and thermoforming polystyrene foam type of application areas are now being banned. Okay, so this has to be product has to be properly selected if you are selecting this type of application, because if you give order and then you understand that, okay, my market is very less and I need to have pollution control license and all that, then it will be creating issues in future. Okay, so that it should be properly selected. The product, whichever you may be selecting, it should be properly selected, and then you have to go for a machine ordering. Disposable syringe also can be one of the major business areas, because these are definitely being used everywhere. Now they have started giving vaccines for children also. So this syringe will have very good market, and definitely there are 2 to 3 main products manufacturing this particular syringe. Like it may be a BD manufacturer is one of the manufacturers, BD, or Dispovan is one of the manufacturer. So they are manufacturing these syringes, and then they are packaging into a particular packaging application film, and then they are mainly doing some sterilization also on that particular application. So then they are supplying in market. So this type of application also, wherein you can use for syringe manufacturing. So syringe again can be manufactured in 3 products, like it may be a plunger, which is injection molded, cover or a body, which can be injection molded, and then you have a black o-ring, which is silicon based material or rubber based material. So that can be again injection molded. So these 3 different molds you need to have, and then later on you need to have this particular marking system, wherein that ML marking also has to be done. Okay, so this is also one of the good product. So you need to go for injection molding process. You can also manufacture this type of syringes for veterinary applications. So veterinary applications will be having a larger size, like it may be 60 ml, 50 ml, 100 ml, 150 ml and all that. So larger sizes of syringes will be used in veterinary applications, like for pets, like you have cows, buffaloes and all that. So in that case also the syringes will be used. Okay, so this also is one of the good product. So you use again injection molding for syringes. Same way, there are so many containers which are being manufactured in injection molding. You have these food containers, you have containers which are used for storage of ornaments and all that. So these all are manufactured in injection molding. So any type of this type of product can be selected, and you can go ahead with manufacturing. So only thing is that you need to see that thickness is more than what is given inside your SOPs. So single use plastics thickness should be properly mentioned and followed. So that has to be taken care of. Again, it can be used, injection molding can be used for manufacturing of crates and all that, which are used for vegetables, packaging of vegetables and all that. So this also is very good area wherein you can start your own business with a small investment, and you will have always some amount of work which is being carried out. Okay, so injection molding is one of the good area where you can start your own business. One product which I would like to show you here is again this particular silicone molds, which are used for manufacturing of your decorative earrings or nose rings and all that. So these also are good products. They are being supplied in market, wherein they give a complete set of systems, wherein they have metal clips, they have hanging systems, they have molds, materials, everything is being given inside a set. And this molds basically, which you can see different designers molds which are there, these are silicon material molds. So this silicon material is again injection molded, and then these molds have been formed. So inside your own house itself, you can make this small design earrings and all that, and you can wear it as per your dress color or as per the size and shape requirement. So this also can be done. So this also is one of the good product which is been in market. So these are hot selling products which are used for children and ladies applications. So these are good products. You can just think of that also in market. We have spectacle frames. So injection molded, again you have injection molding for frames. So these both frames are then assembled. You have this front frame which is again injection molded. You have this container in which your frame is being stored. So these are all injection molded again. So this can also be one of the good product. And again children, they have a requirement, okay, so my frame should match with my dress color, so that also is one of the requirement. So then they can go ahead with this type of injection molding of frames, different color frames also. Okay, so these are the injection molding setups which are available. Many times people or entrepreneurs start with one machine, and then they can go ahead with multiple machine as per the requirement. So you can see the setup. So a lot of automation is being taking place. You have automatic loading of material, you have automatic removal of finished products and all that. So this is all possible, and this is all taking place in injection molding. Since it is a very old process and started from very old long back, so a lot of developments have come ahead, and bigger machine development in terms of bigger machines, smaller machines, micro injection molding machines and all that. These are all taken place, and a lot of products have been manufactured in India also. Okay, so India also has so many machine manufacturers. So they are locally producing these injection molding machines and supplying in market. One of the product which I wanted to discuss, since we were discussing SOPs, so mat manufacturing can also be one of the good business area. So mats are used for storage of food grains. If you go in agriculture field, they are used in storage of food grains. They are used in for yoga mats also. You must have seen so many mats are used in yoga application also. So mats have so many applications. Agriculture, you have other areas, storage areas, chemicals and all that, also storage of chemicals bottom also you can keep this type of plastic mats and all that. So these mats are being manufactured by using extruder. It is a single screw extruder wherein tubes will be manufactured. So standard length tubes are being manufactured. These tubes may be 1 meter or less, it may be the length of the tubes, and then these tubes are fitted inside this particular mat making machine. So these are bigger machines which are available for making different mats. So there you can have different color tubes which can be fitted, and then they may be fitted inside this particular mat making machine, where they may be interlinked and then connected inside, and then that mat will be formed. Okay, so this is a basic mat making process. So this also can be you can also use here recycled material. You can use recycled material for making the tubes, and definitely your mat cost also will be coming down. Okay, so this also can be one of the good product, mat manufacturing. So again, there is no standard which is available for mats. So again, you can go for your own manufacturing as per your requirement, market size and all that. So you can start this type of activity also. Toothpicks, again, toothpicks was one of the product which basically SOPs we need to check, but toothpicks was also one of the product. So toothpicks were used in wood, they were made in wood. Now they can be used in or made in plastics also. So this is basically a small extruder, and then it is cut in a particular angle to make it pointed. So this also can be one of the application. But these toothpicks and the small products, single-use products, will be issue in single-use plastic. So that also you need to think properly. But the product is good. You can get that machine in a cost of approximately 6 to 7 lakhs. Also, you can get that type of machine, toothpick manufacturing machine. So this can also be one of the good product. Okay, so instead of wood, you can go for plastic toothpicks. So this also one product can be thought of. You have cables, wires and cables. So coating is done through plastic, and inside you have copper or aluminum. So coating material can be plastic material. So you have nylons, you have polypropylenes or other PVC material also can be used for coating. So this can be also one of the good product. So PVC wires or coated wires, nylon wires can also be made in wherein fire protection and other flame retardancy properties are required. You can also have PVC insulation tapes. So insulation tapes, there was no standard before, but now ISI standard is available for insulation tapes also. So you need to make that tapes as per the standard. So these tapes also can be one of the good product. Like you can have this film from market, and then that film can be cut inside into small sizes, like it may be 1/2 inch or 1 inch tape and all that. So that can be winded in a machine. So this can also be one of the good product. Other product which can be used or can be manufactured at a smaller quantity is your this particular sellotapes, which we basically call sellotapes. In terms of brown tape or transparent tapes can also be one of the product. So this machine, if you see, it may be costing you approximately 50 to 60,000 only. So cost is very less as compared to other machines, wherein smaller production capacities may be available. Wherein if you need to have bigger capacities, like if it may be 1 meter or above, that particular tapes have to be cut and then have to be winded. So there also again you can have this type of bigger machines which are automatically run through motor system. You can control the speed, you can control the winding speed and all that. How much should be the tape width and all that also can be controlled here. So this also is one of the good application area, which is basically tape manufacturing. Okay, so brown tape or cello tape can be one of the area. You can also use you can also manufacture PVC HDP pipes. So PVC, UPVC or HDP black color pipes can also be manufactured. So you have this extruder machines, which are pipe extruder machines, which are available. So these are again application areas. Basically, it may be agriculture, it may be for building construction application areas also. This drain water system and all that, this type of application also, this pipe may be used. Okay, so this is also one area. So black color, which I was discussing regarding extruder of HDP pipes. So these are basically drinking water application pipes. So for drinking water, this type of pipes are being used, and they are basically extruder, which is there. It has a cooling and sizing unit. Then you have a caterpillar cutter, or it may be a winder. If sizes are less, you have a winder system wherein you can wind that coil type of pipe on that winder, and then you can supply in terms of coils also. Okay, so this also is one of the application area for HDP pipes. And now these HDP pipes have good market area because a lot of government force is there on drinking water application, agriculture water applications and all that. So most of the application area, these black color HDP pipes have been used. Okay, so this also has very good market. So you can also think of this HDP pipe manufacturing. Raincoat manufacturing also is one of the area wherein you can take a film and then you can cut it as per the requirement sizes, different sizes, and you can heat seal it, and then you can manufacture raincoats also. So this also is one of the good area wherein either you can take sheet or film from market directly, and then you can only cut and seal and make this raincoat, or you can also take raw material from market. You should have a blown film or a sheet extrusion plant, and you make your own sheet or a film, and then you cut it and then make into raincoats. Okay, so this also can be one of the good product, because every rainy season, definitely children, they will be requiring this particular new raincoat in every rainy season. They will not be using old raincoats and all that. So definitely that also will be a good application area, raincoats. So this also can be thought of in that case. Okay. Then you have water storage tank, that is rotational molded product, which can be manufactured. Rotational molding products in terms of different sizes. It may be 500 liters, 1000 liters, 5000 liter tanks, which are available. So in rotational molding, you are taking raw material in powder form, you are putting it inside a mold, then you are closing the mold, you are heating the mold inside a heating chamber. Again, your mold is being rotated in biaxial rotation. So you have 2 axis rotation which is taking place. Your material will melt inside, and then that material will be sitting inside your mold. It will be taking the shape, whatever shape your mold is there. So once after heating cycle, then it goes to cooling cycle. Cooling cycle, you cool the mold. Then once mold is been cooled, your product is getting cooled. So you open the mold and remove the product. Okay, so this also is nothing but rotational molding process. So different size of products can be made here, rotational molded products. And water storage is one of the major application area where these rotational molded products can be used. Nowadays, rotational molded products are also used for drainage system, drainage tanks, chemical tanks, or they may be used for roadside barriers and all that applications. So these are all application areas where these rotational molded products have been used. Okay, so this is a good application area. A lot of our recycled material can also be mixed with virgin material, and that can be used for making these tanks also. Okay, so this is rotational molding machine I have just shown you here. So this is multi-arm machine wherein at a time you can make 4 or 8 tanks, and the tanks will be rotating in biaxial direction. They will be going inside a heating chamber. Once heating cycle is over, they will be going inside a cooling chamber. So cooling chamber may either have a fan system, or it may be water spray system which will be available. So water will be sprayed on the mold, and then once cooling cycle is over, you can remove the mold, you can remove the bolts from the top, and you can remove the product from inside. Okay, so this is rotational molding process. Again, there are different products which are in demand in market. Like it may be products which are related to our electronic goods. It may be hanging type of charger. It may be white good applications like your toothpaste holder or toothpaste dispenser and all that. So these are all fast moving goods which can be easily made in your injection molding, or it can be made in blow molding, and then that can be put inside market. So once if you put in market, you get lot of demand, you can produce it, you can supply it, and once it is common, the product is common or getting popular, you can go ahead with some different product. Okay, you can change your product or change the design and all that. So you can go for a new mold and then you can change the system also. Products can also be changed. So this are the products which are in demand and then that can be manufactured. One process which I would like to show you here is melt blown process, which is used for manufacture of your mask, face mask, that blue color mask which we can get. So that is called as melt blown process. So in melt blown process, you have a resin which is added, basically PP resin is added, and that is melted inside the die. You are forcing hot air inside this die. So your material plus hot air, it is been forced on a moving device. It is forced on a moving rotor basically. So that rotor may be made up of steel. It is in cold condition. So this is a screen collector or a rotor. So with very high pressure and this hot air pressure and this material, it is getting mixed and put on the roller. So once it is falling on the roller, it will be getting cooled. Then it is going through a calendar system wherein it will be pressed and your particular mask will be made. So this raw material for mask or the fabric for mask will be made. So it can be either white color, it can be blue color also as per the requirement. So you can see the left hand side photograph wherein you can have a die. You have a hot air blowing system which is available on the sides, and then it is falling on a roller. So this roller is rotating continuously, and once it is getting cooled, that material is getting cooled, then it is winded on a winder. So there is a white color, you can see winding which is available on the right hand side. So this winding is taking place. Once it is cooled, then that winded material, that roller, is then removed from this machine and it can be fitted inside your mask making machine. So this is the mask making machine wherein you have a blue color roller, you have a white color roller system. Like if you have a 3-layer mask, 5-layer mask and all that. So this can be fitted on a roller of your mask making machine. Raw material, it will be as a raw material, it will be fitted. And then this material, these layers will be going inside the machine. They will be converted into mask. They will be having a folding system. They will be having a system wherein you can weld that particular threads on the sides. So all this system is available in this machine. So these masks are being made and then it can be supplied. So these machines were very less before Corona, but after Corona, definitely every district, every state, they have been this setup of mask making available, and a lot of business opportunities are definitely available in this area also. Okay, so this is mask making machines. So again, it is plastic only which is been made. So you have so many PP kits material which are again available. So PP kits in terms of face masks, in terms of sanitizer bottles, in terms of dispensers, gloves and all that. So all these are all materials which are again made up of plastic. So this also has demand, good demand. Still Corona, it has not gone. So they will be having demand for at least 1 year more. So these are also great demand products which are available in market. Okay, so these are all basically materials which are there for PPE kit. So these are against the coronavirus protection, it will be used. So this is some of the products. Just I have shown you some photographs. So thank you. I think I can finish my presentation. So if any questions are there, you can either put it here or we can, I have just given my number also. I think email ID I have given. So you can ask me there also some questions if it is there.
Thank you, sir. Thank you very much. As we have offline and online, both the participants has many questions to ask you. They want to know many things. Good afternoon, sir.
Yes, ma'am.
So I'm a student of CIPET Guwahati. I'm pursuing diploma in plastic technology.
Okay.
The question is EcoBrick safe for replacing non-recyclable plastic waste?
See, eco bricks, again, application area is very important because they may not be used in application areas where our normal bricks like burnt bricks or cement bricks are used. They may be used in application areas like seashore. I have just explained you. It may be used in seashore wherein they need to protect against waves, or there should not be erosion of soil in that area. So there you can use that type of application areas. Secondly, this was only one of the concept which a particular NGO must have made. So we need to check thoroughly that what will be the life, how much will be the life for that component, and what may be the side effects. Like suppose if you are putting that waste inside that plastic bottle, PET bottle, so after particular 1 year or 2 year, will that bottle crack? And will that material go outside and then it may create more problem inside, pollution problem or waste problem. So that all points needs to be checked properly, and then you can go ahead with that type of application.
So there is another question.
Good afternoon, sir. My name is Kasuri Borde from CIPET-GUWAHATI. So my question is, which department calculates the plastic consumption? Is it national or international department?
See, consumption of plastic waste, again, there are different bodies. Like suppose CIPET also was given some particular assignment. Maybe 10 years back, we were given assignment by Central Pollution Control Board. You can find out how much is the plastic waste generated in a particular district. Like suppose I was there in Murthal or Panipat. So we were told that you find out how much is the plastic waste generated in Delhi. So then we went to different areas. We went to manufacturers, then we went to land filling site also, wherein we found out we have collected some sample waste materials, and then we have found out, suppose I have taken a sample waste from one particular land filling site in Delhi, and I have segregated that material. It has organic waste of 500 grams, it has plastic waste of 100 grams, 50 grams, like that. And that also we have segregated in terms of PET was how much, PP was how much. So that type of assignment was given to us in that application area, wherein we were given assignment by Central Pollution Control Board. So when we say plastic consumption data can be received from import export ministry. Like it may be import export ministry, like if you are importing raw material from outside, so we can get that type of data from import export ministry, like Ministry of External Affairs and other ministries, wherein they can give us what is the import value of plastic raw material. In that also they can give you what is the value of PP raw material which was imported, how much was the export value, what product are exported at the highest rate, and all that. So that import export values can be giving you the consumption also. Secondly, consumption can also be in terms of Ministry of Chemicals and Fertilizers also. If we are petrochemicals, because chemicals and fertilizers, our own ministry also has a department of chemicals and petrochemicals. So how much are the petrochemicals consumed in the country? Like suppose PP raw material, so what is the consumption of PP raw material? So that values you can also get from the department website also. What was last year consumption, what is this year consumption? So that values, they are always updated, and that you can get it. Then you can ask me, sir, where does department get these values? उसको values कौन देता है, department को कौन provide करता है? तो definitely that values they will be getting from manufacturers. They will be getting manufacturers values like Reliance, Haldia, HPCL, IOCL. So they will be also giving, sir, we are manufacturing 1,000 tons of PP material per day, or we are manufacturing this much quantity, and every material is going in market. So that values also they will be taking, and then they will be putting that values inside. Then manufacturer side also you can get values, like suppose you have a major manufacturer like Uflex. Uflex is one of the major manufacturers. They are making a lot of plastic films and other packaging application films. So they have very big capacities plant setup. So then values of production values can be get from that manufacturer also. So if particular state, you can get that type of values, and then that values combine or summing up all these values, you can find out what is the production value, what is the consumption value, application area wise, material wise. So all that also can be taken from the market. So it is possible. And international organizations are also there. They will be also showing you values. So there are a lot of organizations like NGOs and all that, they are also working. So if some NGO is there who is operating in Delhi, then he can give you the values for Delhi also. Like Delhi, so much waste is generated and so much waste is being recycled. So that type of values, their own survey also they can do, and they can give you the values. So it is possible.
Thank you, sir.
Good afternoon, sir.
Yeah, tell me.
Sir, I also have a question, sir. As you know, most of plastic wastages are produced from packaging sector. These are being wasted without recycling. Sir, I want to know how we have a control over the production of huge amount of packaging waste. Any suggestions, sir, to the industry or manufacturer for avoid or reduce unnecessary packaging?
See, so that only we have seen in presentation. So most of the packaging waste which is generated it is basically that waste which is single use plastics. Okay, it may be carry bags, it may be packaging applications for food, it may be packaging application for food grains, for packaging of consumer products and all that. So if that type of waste is getting controlled, and if you see lot of waste which is seen on roadside or landfilling, so that waste is again packaging waste only. We will not find anywhere that glass bottles are there or metal is there, or there are PET bottles which are lying. Most of the waste which is going is packaging waste only, and that waste can be controlled only when we use these guidelines which is now being given by CPCB, wherein they have mentioned the thickness values. Okay, so thickness values are very important here. So if you go for manufacturing above that thickness value, definitely costing, definitely recycling, like suppose cost of the bag will increase. So when I'm going in market, and if that particular big bazaar or some chroma, they will tell, no, you have to give 5 rupees, 10 rupees for that bag. So then you will say, no, I will not spend 5 rupees or 10 rupees. I will bring my own bag from home. Okay, so that type of application wherein you are avoiding to use that bag. So that type of application, if increases, then this wastage will be reduced. Secondly, when you are increasing thickness, that product can be segregated easily. It is having good weight also, because thickness is been higher. So you can go for recycling of that material. Okay, so recycling is also possible. You can go for recycling, like mechanical recycling and all that. And it will be easy for recyclers because it will be separated out. It will have huge demand in market because raw material rates are increasing. So everybody will go for recycling. So recycling products also will be manufactured in a large quantity. Definitely your recycling raw material also will have good market demand. So this problem of packaging of this particular application will not be there. Secondly, you can go ahead with then biodegradable packaging. You can go ahead with that type of application areas, but definitely cost of biodegradable packaging is higher as compared to normal packaging. So that will take time, but one of the option is biodegradable packaging also, which can be used in application areas.
Sir, actually, sir, in the point of green chemistry, sir, they said, sir, it is better to prevent waste than treat or clean up waste after from it, sir. And sir, some people, when I see from the market, I buy any product, sir, I can see some people only do so for showing their product quality and brand value, sir, and only for marketing purpose, sir. How can we build some rules and regulation to prevent those unnecessary packaging, sir?
See, again, I can give you a good example, that is Amazon. Okay, so first Amazon, if you see packaging which Amazon was using, it was plastic film which was less than that particular norms which was mentioned. Secondly, now since government has started putting levies, they have started punishing these people. So now this Amazon or Flipkart, if you see packaging application now, they are using paper now. Okay, so they are using paper or they are using film which is having higher thickness. So more thickness film they are in. So it can be done, which I have mentioned, that priority areas. So priority areas which I have mentioned in my presentation, wherein they have showed that, okay, we are giving consumer this particular application, okay, you can use this type of material or you can go for alternatives and all that. If nothing is happening, if so, after so many rules, regulations, so many what we can say, suggestion, if people are not using or consumer are not using, then finally I think government will go for levies. Okay, so levies or taxes, like we have a education cess which is been put on every material we purchase, and that tax cess is been put. Then there is Swachh Bharat cess which is been put. You will understand that after 1 or 2 years you will have a particular cess on plastic waste management also. So you will have a 5 paisa or 2 paisa which will be cut from your purchase for, and it will be given for plastic waste management, and that amount which will be collected all over India will be then used for developing of recycling systems or segregation systems or waste management systems and all that. So this will be last step wherein that cess or levies or taxes will be put. But before that, if this problem is getting solved, then I think there will not be any issue. So consumer awareness is very important. And then that producer, extended producer responsibility. So that producer should also understand that it is his responsibility. He should use minimum of that type of packaging, and then he should avoid that type. If suppose you are buying a very small product on Amazon and he is packaging in a big application, and you find that that product was only 50 rupees and packaging cost itself is very high, then they should be educated, okay, you should go for some other form of packaging and all that. Okay, so that's why Amazon and all that, they have all started with paper packaging. So again, we know what are the advantages and disadvantages of paper packaging. So that I think no need of discussing that, because since paper, again, you need to cut down trees and then you have to recycle paper. Recycling paper requires a lot of chemicals, lot of water systems are there. So many issues are there again in paper also. So again, most common is you increase thickness. Okay, you increase film thickness so that this issue of recycling will not be there. So they will be easily collected, easily segregated, and converted into some useful form of products.
Thanks a lot, sir.
Madam, we cannot hear your voice.
Sir, one participant has question. He wants to ask. May I proceed for
Yeah,
that?
madam, you can
Time
ask. No
constraint
problem.
is there.
Or he can write in chat box also. No problem.
Yes, sir.
Any more questions? If it is there, we can take it tomorrow also. So tomorrow also I have my presentation.
Okay, sir. Thank you.
Yes, sir. Then tomorrow, sir, I asked him to.
Yeah, you can tell him that he can
Doubts,
give for
actually.
tomorrow also. No problem.
Sir, thank you very much, sir. As all the participants are very much benefited from this talk, and as because not it is only informative, but also the presentation is also very interesting, and every discipline's participants could easily understand the ways, then how to what are the rules, then what are the extended producer responsibility, then alternatives for single use plastics, and how the manufacturing process is also there. And even I had also many things to know, sir. So but tomorrow I will ask her. Thank you
Okay.
very much, sir. And I,
Thank you,
on
ma'am.
behalf of CIPET CSTS Guwahati, thank you very much for spending your valuable time during this busy schedule. And we feel happy that we got these lectures, because as you had earlier said that you had some other meetings, but luckily we are able to get it. And other participants has also questioned, they have raised their hands, but we will go for that tomorrow, sir.
Okay, madam.
So,
Thank you.
thank you very much, sir.
Thank you, madam. Thank you.
So dear participants, now lunch break is there from 1:30 to 2:30 p.m. Lunch break is there. After lunch break, we will meet again at 2:30 p.m. So online participants can be at the same line, or they can rejoin the link again. And as per the schedule, in the afternoon session, we have tool room demonstration. Here, a briefing will also be there, just like the yesterday's. And after that, we will go for the live demonstration. So please join on time. And now lunch break is there. So you can go for lunch, and after that we will meet again at 2:30 p.m. Thank you. Dear participants, we are going to start by 5 minutes. A very warm good afternoon to all of my dear participants. Today for this session, we have with us our resource person Naimul Islam from CIPET CSTS-GUWAHATI. He had experience of more than 15 years in the domain of design, production, and processing, and he is an engineer of toolroom CAD/CAM. So he had expertise in design, then toolroom, and how the mold are manufactured for that. And along with, apart from this expertise, he is an recognized inspector for post-delivery inspection of plastic products, and he provides consultancy services also to various industries all over the northeastern region. So we are very happy that Naimul Islam sir is with us. So over to you, sir.
Good afternoon to everyone. Thank you, Jyotika ma'am, for giving me an opportunity to give a speech on tool room department. So I would like to give a brief description of facilities available in CIPET tool room. Basically, in tool room department, apart from giving training to the long-term and short-term trainees, we are devoting technical support services to allied companies in our northeastern regions. So in our tool room department, we have divided our machines into two categories. One is conventional machines. Conventional means that are manually operated. In conventional machines, we have lathe machines where we can perform turning, boring, facing, threading and all. Mostly circular products are manufactured in lathe machines. Then we are having vertical machines, vertical milling machines, inversion milling machines where we can do rectangular work pieces. Then radial drilling machines for drilling of holes and tapings. Then inversion tool and cutter grinder for sharpening of blades, for sharpening of cutters. Inversion shielding and grinding machines. That grinding itself, cylindrical grinding itself says to make grinding on cylindrical products. Then surface grinding, where you can sharp blades, plates and all. Pantograph machines, we can do engravings of letters, numbers, then any profile logos and all we can do in pantograph machines. Then we are having pillar drilling machines, shaping machines and pedestal grinders. This is lathe machines where you can perform the circular products. There is turning, then facing, then threading. Thread pass we can make it here. This is vertical milling machines. This is universal vertical machines. Here we can make rectangular workpieces. Then we can do gear cutting also we can do it here. Helical gears and all. Spur gears. This is vertical milling machine. This is horizontal milling machine, inversion milling machine. The spindle is in horizontal direction. This is radial drilling machine. It swings in the column. So big workpieces that we cannot accommodate in table that can be mounted on surface also. We can do drillings, and then we can do tappings and all. This is universal tool and cutter grinder machine, mostly used for sharpening of cutters, milling cutters. This is cylindrical grinding machine. This is used for grinding of shafts, then guide pillar, guide bushes. The internal grinding also we can do it here. This is surface grinding machines where you can surface the plates required for various mold plates and grinding of various blades that is used in grinders for scrap such as scrap grinders. This is pillar drilling machines, a small one this is used for mostly in training purpose. This is pantograph engraving machine where you can emboss anything such as logos and all, the numbers and all. This is shaping machines where roughing can be done, roughing on plates, and vertical shapes, V shapes can be done. This is pedestal grinder where you can sharpen our cutters, tools, etc. Then in CNC sections, that is non-conventional machines or non-traditional machines, we are having CNC milling, CNC machining centers, CNC work at EDM, CNC EDM, and CNC lathe. This is CNC milling machine, make Haas, T model TM1. This is CNC vertical machining center, Matrix 560 AP model, made by Hartford. This is a new machine, CNC vertical machining center, JB100, manufactured by LMB, Lakshmi Machine Works Limited. This one is CNC vertical machining center, manufactured by MacPower. Model is Eco 800. In milling machines, mostly we use for manufacturing of core and cavities. Any complex profiles, any complex product core and cavities which we cannot make in conventional machines can be done by CNC machines. Firstly, we have to do programming of all the core and cavities in softwares like InnoGraphics or Delcam or Mastercam. Then we will convert it to G codes and M codes. Then that G codes and M codes, that programs will be inputted to machines. Then accordingly, this machine functions the programs. This is CNC work at EDM machine. This is made by Electronica, and this one is Electronica High Tech Limited. Model number is Toolmaster 6. These both are CNC wire EDM machine. Here we can manufacture complex shapes. At sharp corners we can make it here, spur gears and all, and complex profile, smallest profiles can be made it here. In EDM machines, this in worker EDM machines, this profile is cut by a 0.25 mm diameter wire. This is basically a thermal. Due to thermal generation, the metal evaporates in particles and it cuts down the material. This is EDM machine. Electric discharge machines EDM, where you can manufacture machine the hardest materials, but material should be electrically conductive material. This is CNC lathe machines, where we can put programs. It will automatically cut the workpieces and it gives a very good finish, and it takes very less time. This is used for mainly for production purposes only. In our tool room, we have manufactured many molds. This is the mold for drinker base. This is for poultry product. This is the bucket one, 3-liter bucket we have manufactured in our tool room department. This is the product we have used for DRL. This is diffuser. The second part is diffuser, second part, and this is third part. This is the cap. This is soap container. We have manufactured it here. This is 1 liter mold, PET mold, manufactured in aluminum material. We have manufactured in our tool room department. This is 500 ml PET bottle mold. This is the hydraulic press machines we have manufactured for NEST Guwahati. The right top corner is the deodorant making machine. This is completely hydraulically operated machine. This is a rotary drum where you can make khad from waste foods and water hyacinth and all. This is manufactured for IIT Guwahati Civil Department. This capacity is 2 ton. It can produce 2 ton within 21 days. Then this one developed for IIT Guwahati biogas reactor where then methane is produced through this biogas. They used waste foods and all, that is from hostels and all. They put it here and it gives the gas. This is the ear guard during the pandemic. We have used for in our masks. That is developed for IIT Guwahati. And these are the parties clients we are having. Thank you. Now I will go to tool room department for some practical exercise now. Thank you to everyone. And Mr. Hemen Hazarika will give you live demonstration of all the machineries.
Thank you very much, sir. Thank you very much for briefing all the machineries available at tool room department of CIPET CSTS-GUWAHATI. Now we will go for the demonstration of the machineries. So online participants can leave the link, as because offline participants will proceed for the live demonstration of the tool room department. And we hope and we expect those participants who wants to visit our tool room department, whenever you get time, please give us a mail or make us a call. We will always available there for demonstrating the practical machineries available at tool room department of CIPET CSTS-GUWAHATI. Thank you so much. So I request all the offline participants to proceed for the live demonstration of the tool room department. Okay, before moving to the live demonstration, many participants, online participants, had the queries about the attendance. So for the how the attendance is marked. So it is for your information that attendance is monitored by the Cisco WebEx. Since we are using Cisco WebEx meeting platform, so each and every entry and exit of your at what time you are entered, if someone is suppose left the meeting at the mid, that one is also being recorded. So every attendance is recorded. And thank you for your consistent attendance, because as we have observed that almost all of you are consistently attending the program. So no need to worry for the attendance. Everything is marked and everything is monitored by us. And when we see that participant list also, we have found that all the participants are consistently attending the session. So tomorrow we will meet again at 10 a.m. morning. So Professor Niranjan Karak from Tezpur University will deliver his lecture. So thank you so much.